SQL health check is like a subset of SQL, and I will talk about SQL health check at the end, and also about test case. But the core topic for the remaining of the time is SQLTXPLAIN and how we use SQLTXPLAIN to diagnose SQL statement performing poorly. Again, if you have any questions, don't wait to the end, just raise your hand, ask your question, and we go over that. So the agenda for this, what we have is, I'm going to go over some SQL tuning concepts, then I will introduce SQLTXPLAIN, I will go over installation, the main methods, how do we use the main report, health check, and test case creation and implementation. So some concepts about SQL tuning. Okay, what is SQL tuning? Is this an art, science, black magic, a little bit of everything? It all depends who you ask, right? I remember when I started looking at SQL tuning issue like many years ago, to me it was like black magic. I couldn't make sense. I mean, why we have a SQL sometimes performing fine, sometimes the performance will degrade, and sometimes it will go back to normal. I couldn't understand that. To me, it was totally black magic. That's understandable. When we're trying to define what is actually SQL tuning, you may find different definitions. It all depends who you ask to. Some people will say, okay, basically what we want this SQL to run faster. That's what we want. Some people will say, you know what, this SQL was running fine a couple of weeks ago, but suddenly it's taking longer. Or we did an upgrade and my SQLs are being affected. I need to find a way to improve them back to whatever they have. To me, actually, SQL tuning is more like this. We want to improve the performance of a SQL statement in such a way that it satisfies whatever is my business requirement. For example, this morning I was looking at this email on this distribution list that was saying something about indexes. And this application has many indexes, and this person was complaining about the indexes, trying to convince development to drop the indexes. And it was going on and on and on and on. And there was a lot of people offering some advice, saying, okay, you can use a index monitoring to determine if those indexes are being used. If they're not being used, you can drop them, or you can look at the history of the execution plans out of AWR. If you don't see this index, you may want to drop it. I didn't offer my opinion in that time because the thread was already quite long. But my opinion in those cases is, who cares? Who cares? I mean, if you have many indexes and nobody complains, I mean, the business doesn't complain, who cares? Only focus in those issues which are affecting your business.
So that was the performance key. Some just said there were too many indexes?
There were too many indexes. Yes, and he was trying to convince the development group to drop the indexes. The development group was saying, no, we need those indexes. And it was this polemic about, I mean, who was right? And a lot of people, they offer some advice. But to me, like, who cares? I mean, as long as it doesn't affect your business, you shouldn't go and try to fix everything that is wrong, because you will go crazy. I mean, it's right. I mean, take any SQL, well, almost any SQL can be improved. So it's very easy to be kind of a little bit obsessive. I mean, trying to fix everything that is taking long.
God just says obsessive tuning disorder.
So you know about that term, okay? Yeah, and it's true, and you see that often. I mean, it's like if you are hammering nails every day, right? After you're finished with your work, whatever you see, you're just looking at people. They look like nails. You want to hammer them. It's the same with tuning. Once you get used to tuning, you see that SQL, you immediately want to jump in and try to fix that SQL. But the question is, does it really matter? Is it affecting your business? If the answer is no, forget about that. You see people, you see DBAs, they look at AWR, they look at the top SQL and they say, oh, this SQL requires some tuning. I would say, no, not necessarily. If that SQL is affecting your business, I agree. But if it doesn't affect your business, imagine if this SQL is coming from this report that is taking 3 hours to run, and you run the report once per year. Well, who cares if the SQL is taking 3 hours, right? So that is important. Every time you are trying to think tuning, think if it is affecting your business. And another thing I want to mention here is you are trying to minimize resource utilization. Why? You also see people that say, oh, this SQL is taking a long time. Let's get Exadata. Let's say do parallel execution. Of course, if you do parallel execution, you may improve the performance of one SQL. But how is that you are affecting other people on the same server? So it's like, no, you don't tune with parallel execution. You don't do that. You tune your SQL. I mean, your SQL is business critical. You tune it serially, on a serial plan. And once the serial plan is working fine, if you still want better, then you consider parallel execution. But don't try to use parallel execution from the beginning. Is that clear? So anyway, that is the way I see SQL tuning today. But, so it went from black magic to basically focus on the business. Don't overdo this, and always think whatever method you use for your SQL, think that there are other people using the same server. So don't go with parallel execution like crazy. So another concept here, what is query optimization? Query optimization is not the same as SQL tuning. SQL tuning is our work. Query optimization is part of the CDO. The cost-based optimizer is doing the optimization of the SQL, which is not the same. We have to collaborate. I mean, we help the optimizer, and if the optimizer is like a person. If you are nice to the optimizer is going to be nice to you. Is that right? I mean, if you are mean to the optimizer, guess what? The optimizer is going to be mean. Okay? So just think that way. That is the optimizer. So the query optimization is the process that it's going to take your SQL, but it's a program. It's going to take your SQL, it's going to create an execution plan. When we're thinking the optimizer, we're always thinking, oh, this big program is going to create an optimal plan. That is false. The optimizer is going to try to get one optimal plan. But how do we define optimal? Well, it's going to be optimal in terms of cost. Usually, cost correlates to performance, but it's not mandatory. Is that clear? So the optimizer is going to optimize cost. If we provide to the CBO good input, that means the CBO, when it optimizes cost, that cost may be closer to your performance. Is that clear? Just think that way. The optimizer is quite complex, it's resource intensive, it will take some time to come with an optimal plan, not necessarily the best plan. So it's going to input some knowledge about your data. In most cases, it won't use dynamic sampling. So that means whatever the code-based optimizer generates as an execution plan is going to be based on what? It's going to be based on statistics, binds, access methods that we provide, parameters that we specify, but not in our data. So if the statistics are saying I have 3 rows, and in reality I have 3 million rows, well, the optimizer doesn't know that. The optimizer is thinking 3 rows. Is that clear? Just keep that in mind. How accurate it's going to be? Well, it all depends how good is the quality of the data that we present to the optimizer. If there is a correlation there. The optimizer has to balance these two, flexibility, stability. There is always this trick, trying to balance these two. There are many parameters, like hundreds of parameters. And on top of that, we're expecting the optimizer to be fast, less than 1 second. That is what we expect. Whenever we ask the optimizer to generate an execution plan, we're expecting to be fast. When you put everything together, guess what? In most cases, you will get a reasonable plan, but in some cases, your plan is going to be suboptimal. Does it bother you? If it doesn't affect your business, nobody cares. Now, every once in a while, you will get a suboptimal plan that bothers your system, that bothers your business. In that case, we need to do what? SQL tuning. Okay? Keep in mind, statistics are very important. I have said this several times, but they're extremely important. And when we're thinking statistics, keep in mind, it's not only schema of the statistics, we have all these other pieces. One of them that you really want to look in detail is the one here, extended stats. For SQL tuning, this is like magic, extended stats. They really help. But it requires some setup, it requires some understanding of extended stats, and it requires some implementation of extended stats. But it is very good for SQL tuning. So why do we get a suboptimal plan? I mean, why are we here? I mean, why are we taking this class on SQL tuning? Why do we get bad plans? There are many reasons. They go from statistics, they go to not to use the default parameters. I mean, you see a lot of people today trying to tune the application by tweaking CBO parameters. And this is sad because there is no need. I mean, you don't go by SQL tuning by just guessing, trying, trial and error. Tweak this one because I saw this one on this blog, or I saw this parameter in this other database, and I want to tweak this parameter, and hopefully it's going to fix my issue. It shouldn't be like this. It should be like you do a deep analysis, and once you understand the root cause, then you know what is the answer. It will have an example of this game in which, I mean, you have like this small ball, and it only has one hole, and you're trying to make this ball to fall through the hole, and you're trying to find that point where it goes through. Tuning, it looks like it is like this, but it shouldn't. It shouldn't be something that you're just guessing, I mean, what is going to happen. Reasons could be many, but that's why, I mean, we need to analyze and investigate the root cause, and that is not easy, finding the root cause. So, some heads up. I usually do tuning like in 2 steps. The first step is sanity checks. Why? Because doing some sanity checks could be very fast. For example, if I am expecting to use an index here, the first question is, do I have the index? It sounds simple, but sometimes the index is missing. Sometimes the index may be invalid. The index could be unusable, right? So start with some sanity checks. Let's say you're looking at this SQL statement that is taking a long time to execute, it's affecting your business, and you look into AWR, and you're finding that the same SQL has like 50 different execution plans in the history. Well, the fact that you have 50 execution plans, that means what? Plan stability. Okay, so your SQL in terms of execution plan is not stable. What are the main reasons to have unstable plans? We mentioned that yesterday. No, having binds together with histograms. Then, depending what you see on the sanity check, you say, you know what, I see too many plans. I am suspecting plan stability. I am suspecting binds. I am suspecting histograms. Is that clear? So you, just by taking a quick look, you start having some ideas what is the next move, the next step. Another one. Imagine you see on your execution plan, you see nested loops all the way up and down, and you see the actual number of rows is a large number. What is that telling you? If you look at the execution plan and you see the actual number of rows and it's a large number, and you see nested loop, nested loop, nested loop, index access, index access, index access, what is that telling you? And it's going to be very expensive, right? So the reason the CBO may create a plan like that is because the CBO is thinking that you will have only a few rows. So the CBO is making a mistake. I always say the CBO is like my mother-in-law. Once you make the first mistake, you are doomed. Okay? So that is the CBO. Once you make the first mistake in the execution plan, you are doomed. Everything else is going to be kind of incorrect. Okay, so the trick is finding where the CBO is making the first mistake. So when you see a lot of nested loops and you see large number of rows, that is a red flag. Stop there and see you say the CBO is making a mistake. Now my objective is find where the CBO is making the mistake. Go ahead.
The question. So the CBO doesn't look the exact data that is in the table, but it's just making use of the statistics that is available.
That is correct.
In the statistics, it says the table A, B. So the table A says only 3 rows, and the table B says it's millions. In fact, the table A has thousands of rows, right?
Uh-huh.
So when you look at the execution plan, the plan is also going to say the same 3 rows and million rows.
Yes.
So how do you understand why it should be the nested loop with a large number of rows?
Okay, when the execution plan is created, it's using estimated number of rows, which are coming from the statistics. The actual rows that you see on the execution plan, they are populated after the SQL is executed. So those 2 columns, estimated and actual, they are computed at different times. Estimated is when it creates the execution plan. Actual rows is when you actually execute the plan. It's too late to change the plan.
Okay, so that's only with the help of ticket proof or the SQLT plan I can give that.
Yeah, for SQL tuning, it's crucial that you get to see estimated number of rows, actual number of rows. Because you have to have the 2 sides of the story. If you only have one side of the story, you will have to be guessing the other one. And SQL tuning doesn't like guessing. Because guess what? Every time you have a guess on SQL tuning, there are dozens or maybe hundreds of possible reasons why you have that thing that you see or the thing that you don't see. So instead of guessing, just be sure that when you are actually engaged on a SQL tuning issue and you have to actually drill in and find what is the root cause, it's pretty much mandatory that you have estimated number of rows and actual number of rows. Otherwise, you have to be too good to say, oh, just by looking at this plan, I can say this plan is bad. I cannot do that. You have to have both. Okay? Sorry. There are some other heads-ups. Sometimes you look at the SQL, you need to understand the SQL. You cannot miss that part. I mean, your SQL is long, well, you have to invest more time, but you need to be able to understand the SQL. Okay? So when you read the SQL, sometimes just by reading the SQL, you find practices like this one here. Is that my voice? Good? Okay. Okay, so what do you see that is wrong here? Look at this predicate that we have. What is wrong with this predicate? Yeah, we have a decode, but what is wrong here? What are we telling the optimizer here? How do which table we join to which table? Or do we have a join or we don't have a join?
It's not a join.
Is it a join or is it not a join?
It looks like a filter. To the optimizer, it looks like a filter.
For optimizer like a filter?
No, it's a join based on the condition.
It's a conditional join, right?
It's a dynamic condition.
It's a dynamic, we can call this also dynamic join. We're saying, okay, if the value that we pass here matches this value, then this is the output of the decode. Therefore, my statement becomes P1C1 equals P1C1, which means no join. But if it matches this value here, then we join against this table.
Multiple plots.
Well, actually, the CBO can...
Actually, that could be a Cartesian or semi-Cartesian.
That is this for the... Imagine now that you are the optimizer. What do you do? I mean, do you join or you don't join? It's tough, right? So it's like flipping a coin. 50% of the cases you will take the right path, and 50% your execution plan is going to be poor. You throw a couple of statements like this inside the same SQL, and then the chances to get a good plan are minimum. Most probably you will get a suboptimal plan. The results are going to be fine, but the performance of that plan is going to be poor. So when you look at the SQL and you find like bad practices of coding, you say, you know what, it's going to be tough to the optimizer to create a good execution plan. It doesn't matter how you do it, it's going to be tough. So in some cases you have to step back and you have to fight with the developer to fix the code. Okay? So SQL tuning is not like always you take this path. I mean, you review high level, you do a lot of sanity checks, you review the SQL text, you look at the shape of the execution plan to see if that shape makes sense according to the volume of data that you're working on. And then you start saying, okay, let's say I look at many nested loops with, I am assuming here the CPU is making a mistake, so I'm trying to find where is the mistake. But if I see this one here, I say, you know what, this is bad coding, I have to go back and change the developer and question the developer why developing code like this and how we can make this better. How can we rewrite this SQL to perform better? Is that clear? So every case is a little bit different. Sometimes you see the statistics, and by looking at statistics, you are finding things that they don't seem to be right. For example, you have an index that has one column, and when you look at the number of distinct keys, it says 300. When you look at the number of distinct values for the same column, it says 3,000. There is a mismatch. One of the two is going to be wrong, and one of the two may be right. Is that clear? So some of these health checks that you can perform, they're going to tell you there is something fishy regarding the statistics. It doesn't necessarily mean that it's going to be the root cause. But if you see many things about the statistics that are fishy, that means most probably the bad statistics are going to be affecting your plan. Okay? Sometimes you see CBO parameters that over-tweak. You see, okay, I know that this parameter is going to favor the use of indexes, and they also have this parameter that is going to favor the use of full table scanning. Contradiction. So that means whoever is doing the set of the parameters, it may be a little bit lost, and is using some parameters they contradict. So it's like, I would question both parameters. Okay? Key, look at the estimated number of rows, multiply by the starts, and that should be similar to the actual rows. What does it mean? If you look at an execution plan like this one here, look at this column that says starts. Take this column that says estimated rows, multiply these two, and it should be similar to this column here, to the actual rows. Don't just look at this one here, because if you look at one compared to 352, you say, oh, this is a gap. No, it's not true. You need to multiply these two. Okay? Now, when I say number of starts times estimated rows should be similar to actual rows, this similar is kind of very flexible. It's like if it is 10 times more or 10 times less, it is perfectly fine. When it is like 100 times difference, then it's becoming a concern. If the gap is like 1,000 times difference, then it's a bigger concern. But whenever you have to compare these two, don't be very strict. Don't think it's going to be perfect. No, you will have some gaps. As long as the gap is small, you're fine. Now, when you start seeing some gaps, you need to review the execution plan according to the execution order. Why? Because that comment I made before, like my mother-in-law, find the first mistake. But the first mistake is not by reading the execution plan this way. It's by reading the execution plan according to the execution order. So that means we need to be able to determine, just by looking, quick look at this execution plan, what is the first operation to be executed? Here.
Table access customer.
Table access what?
Customer.
Customer. Yes, this one is the first operation in the execution plan. So you get used to read the execution plan according to the execution order. Okay? Because now if I review this one here, say, okay, I have 1 times 2,000 compared to 1,000. That's fine. I look at this one. 13,000 compared to 2,000. It's fine. It's close enough. 2,000, 13,000 is close enough. Okay? When you see the gap is like 100 times, then you begin to worry. But if it is less than 100 times, bigger or smaller, you are fine. Okay? If you are using SQLT, SQLT shows you something similar. This may be a different execution plan, but it doesn't matter. It shows you here estimated canality times starts compared to this one, and they compare it in this column. It's going to say, in this particular line, the CBO is doing an overestimate by a factor of 5. It's fine. When it becomes like more than 10, it's a little bit of a concern. It becomes orange. When it is more than 100, then it becomes red. Is that clear? So in SQLT, what I do, I check this column. If everything is black, it's fine. But if I see like red, then I look in there. And I do that by looking at this column. What is this column? Execution order. So in this one, this is execution order 1, 2, 3, 4, 5, and it goes on. So I can very easily read the execution plan by looking at this column, which I don't have here. Is that clear? So this column here, that was enhancement request number 1 for SQLT, like 10 years ago, or more than that, to show the execution plan, the execution order. And I asked this enhancement to be placed on the ticket roll. It is still pending. In many of the things that you see on SQLT, I open an enhancement request to say, let's improve the product, let's put this on ticket roll. They are still pending. They haven't been closed, but they are still pending. Okay, so some challenges that we may have on SQL tuning. Well, SQL tuning, we have the following challenges. Dependencies. First one, dependencies. In order to, an execution plan is a function of what? Parameters, statistics, binds, access methods, right? And many other things. For example, if my SQL contains a view, well, I also have the dependencies on the object behind the view, right? If I have a function, then I have a dependency on whatever SQL I execute behind the function. Is that clear? The amount of dependencies that my execution plan has is huge. Way too many dependencies. I mentioned here some. Now, some of those dependencies, they are static, meaning they don't change over time, but some of the dependencies, they change over time. For example, statistics, they change all the time, right? Binds, they change all the time. Parameters, hopefully, they don't change all the time, but they may change. The same happens with objects like views and indices that we may create, we may drop. It's like a moving target. If you're trying to understand the execution plan that you have right now, it is enough if you find all the dependencies that you have right now. But if you're trying to see, okay, this SQL was performing fine last week, but today it's broken. You need to understand all these dependencies that you had last week and the same dependencies that you have today. So this is like an extra dimension that you have, which is time. Look at all these dependencies today, and also look at all the dependencies and how they have been changing over time. So that means there is a lot of information that we have. And this is like a catch-22. In order to do some SQL tuning, you have to be an expert on SQL tuning. Well, how do you become an expert on SQL tuning if you never do SQL tuning? Is that clear? So it's very easy to get lost. It's like, imagine you are a DBA working on this company and you are expecting to fix this SQL that suddenly is taking a long time. And there is a lot of pressure to provide some results. If you don't do SQL tuning often, it's like, I don't know where to start. I don't even know what is that I need to look. Is that clear? Why? Because there are so many pieces here. So how do we approach SQL tuning? It was quite often that we were engaged on issues like they will come like this. They will say, I mean, my customer will say, we're having this performance issue since this morning. Everything was working fine yesterday, and suddenly this transaction is not finishing. This SQL is hanging. Then I will say, okay, what have you changed in your system? And guess what is the standard answer? Nothing. So we haven't changed anything. Now in those days, I didn't know anything about SQL tuning. It was black magic. So I would think, well, if they didn't change anything and this SQL is misbehaving, maybe we don't do anything and it will go away. The issue will go away. Right? So that was my technique, right? And I was quite surprised that sometimes it worked. Sometimes I wouldn't do anything, they wouldn't do anything, and they would just close the server request. So that means the issue was fixed by itself. Maybe, I don't know. That was a long time ago. Another way to do SQL tuning is to have like a third-party consultant. And some of you guys are consultants, right? Who's consultant here, doing consultant work? One person, 2, 3, 4. If as an Oracle site, if you get engaged, I mean, you get to engage a third-party consultant and you have good results, a good consultant is like a good mechanic. Keep him for life. Okay? Why? Because you don't get to find a lot of good people on the field. I mean, you get to find a lot of people, but you don't get to find a lot of good people. So whenever you come across someone that is good on your SQL tuning and is helping your environment, my suggestion is keep the guy for life. because the SQL tuning is quite hard. It's going to consume a lot of resources for your site to get to train someone to be good at SQL tuning. And keep in mind, you don't do SQL tuning every day. So anyway, that's just a point here. Another one is to actually get some training, like this class or any other class that enhance your SQL tuning skills. What about this one here? Silver bullets. Everybody wants silver bullets, right? Yes? No? Okay. So you may want to see for some, to look for some silver bullets. I will talk about this one in a moment. Maybe a combination of the above. But what I think, the way we should approach SQL tuning is consider what are the best practices, which are basically just consider a methodology that works. This is what I have to say about silver bullets. When someone is asking me, give me some silver bullets for SQL tuning, that is my answer. I cannot give you anything. I don't believe in silver bullets for SQL tuning. Nevertheless, every once in a while you will find some consultants are going to offer silver bullets. Just be careful, because when you are trying to apply this fix helped this customer 5 years ago and my issue went away, it doesn't mean that you apply the same technique and you will get the same result. It doesn't mean that. So it's very common that you are trying to apply a silver bullet and the issue is going to bite. Just keep that in mind, okay? Any questions, comments? No? Okay, so when I say best practices, really what I mean is kind of a systematic approach. How do we approach a SQL tuning issue? Well, I will say it is like a health check or a checklist that we do. We validate what are the requirements for the business. If I'm working with this transaction, like let's say booking an order, and booking an order should be a matter of a couple of seconds. Well, the business requirement says I need to have that in a couple of seconds. Then, if that is not the case, let's say my transaction is taking 10 seconds instead of 2 seconds. Well, you need to find the bad SQL. Because if your transaction requires a couple of hundred of SQL statements, not everything could be bad. You are trying to find from all these SQL statements which ones are the ones that require more attention. So how do we do that? Well, usually we get traces, like we saw this morning. We generate a trace file. From the trace file, we look at the top SQL. Any SQL that is taking most of the resources. Then the next one, collect comprehensive diagnostic information. This one is quite tricky because unless you know how to do SQL tuning, you are not clear what is that you need to collect. And this is where SQLT is going to help. SQLT helps to collect everything that is needed for SQL tuning, even though you may not know what is that you need. Is that clear? So you have a performance issue, you have this SQL, you run SQLT for this one SQL, and it collects everything that someone that knows how to do SQL tuning can use. It could be yourself, it could be your friend, it could be the third-party consultant, it could be Oracle support. It doesn't matter. What is important here is that we collect everything that we need. Is that clear? And then we perform some health checks or sanity checks. After we went through this one and we do all our sanity checks, everything looks fine. I cannot find possible reasons. I have to sit down and invest time here. Analysis. In my experience, and Abel may have a different experience, in my experience, to analyze a SQL performing poorly is a matter of the least a couple of hours, the most maybe a couple of days, or it will take some time. Abel, in your opinion, how much time, if I give you a SQL tuning issue from scratch, how much time do you need to invest in order to find a root cause?
Thank you for putting me on the spot. Okay. I'm going to answer with an analogy. In support, we do things 3 ways. We do fast, good, and cheap. Since we're already paid, we're already cheap. So from the customer perspective, it's already paid for, very cheap. So either I do it good or I do it fast. So either if I'm going to do it only good, definitely not fast. Okay, so really there is no timing for. I have spent one issue 3 weeks. That's the longest that I've been working a performance issue in which I had to review absolutely everything that I could think of to finally find all the causes of the query being slow. 3 weeks. And of course there was not one issue, there were many. Sometimes just a quick glance can get you some tips there, but there is no good time for it to do any kind of.
But let me ask it a different way. How many SQL tuning issues do you see in a month?
That's even worse. I get like 10 pings a day, 10, 15 pings for people a day that I own, about 3, so like 90 personally.
90 issues, 90 SQL tuning issues per month.
Yes.
Okay.
But if you count all the pings that I get, I don't know. I never take the counting.
Okay, I mean, issues that you work around 90 issues per month that has something to do with SQL tuning.
I would say take 30.
Okay. So, thank you. My number is around 30. I work like on 30 SQL tuning issues per month. So that means, and this is not the only thing I do. I mean, I do different things. So SQL tuning is part of my daily life. Right? Every day I get engaged in at least one SQL tuning issue. And I will say that in average it will take something between a couple of hours, and in some cases, like worst cases, it may take a few days. I never gone like weeks with a SQL tuning issue, but a couple of days is possible. So when I say here you have to invest some time, it really means nothing else. You have to work on your issue one day, maybe a couple of days, to find what is the root cause. Just keep that in mind. It's not easy. SQL tuning is not easy. It takes some time. So in order to do that, we apply this method. You guys remember this from high school, scientific method? Yes? Kind of? Still vague? Okay. So we apply this method, and then we implement whatever changes we require. So what is this scientific method? This is a quick review. This is a description of what is scientific method. I see the scientific method for SQL tuning like 4 steps. We formulate some hypotheses, so that after we do initial review, we say, okay, I'm thinking it is, I don't know, history, or it is bad. Once you have some hypothesis, you are trying to prove you wrong. But one step that we do here, we estimate the gain. We say, okay, assuming I fix this issue that I see on this execution plan, my performance should go from this long to this long. That is what you are assuming. That is your target. In some cases, we have to create a test case. Because if you have this idea, you say, if I were to change the plan this way, I may get better performance. Well, you have to create a test case. Regardless if you need a test case or you can test on the same environment where the issue happened, you have to test your hypothesis. You may need to reformulate hypothesis, and then you keep looking here until you find your answer. Sometimes it's only one cycle, sometimes you go on and on and on, trying different things. Okay? This is another way to see scientific method, but it's the same. I mean, we cannot avoid this. When it comes to SQL tuning, once you have some clues, you have some ideas, you just don't say, oh, this is the answer. No. What you say is, it looks like this is your issue. It looks like if you do ABC, this should be the result. Now we have to try it. Is that clear? That's how we approach SQL tuning. Now, since SQL tuning is hard in the sense that it's quite complex, what are the things that we can automate? Because there's some pieces we can automate. Well, this is just a small list of things that we can actually automate with some sort of tool. The gathering, for example, collecting all the execution plans, collecting all these diagnostic details, meaning metrics, metadata, dependencies, current metadata, historical metadata, everything can be automated. We just need to have the scripts. to collect everything. Is that clear? To extract a test case. That can be also automated. To provide health checks can be automated. Everything that you see here can be automated. And that's what we do. I mean, I will get there. That's what we do here with SQLTXPLAIN. Now, when it comes to using tools, if you don't do SQL tuning often, you will say, okay, SQL tuning I understand is complex, I don't do this quite often, where do I start? Well, I mentioned before that we usually start here with SQL trace, SQL program. What else do we have available? We have the 10053, right? Extraction optimizer, so we get to understand how the CBO works internally. We may use explain plan 4 command, we may use DBMS explain API, we have the auto trace, we have method R, we have trace analyzer, we have ASH. In ASH, we have a lot of information. We can do some data mining on ASH to understand better our execution of our SQL. We have that. We have active monitor report. We have DMS SQL diagnostics, tooling advisor, and of course, I mean I say of course because that's the topic here, we have SQLTXPLAIN and SQL Health Check. Everything that you see here are basically tools that you may want to use when you are dealing with a SQL tuning issue. Now let me talk about this one here because you know pretty much all these tools, right? Do you have any questions about any of these pieces here? No? What is this one here? When I say the tune advisor, who uses the tune advisor? Some people. Okay, most of you guys. And what is your experience with the tune advisor? It's very bad. In which sense?
It always comes back. It always comes back and tells me that there is nothing to advise.
Okay, it's come back. In which release are you at of the database? 11G? From 10G to 11G it has been getting better, but it's not perfect. And
yeah, I did use on multiple occasions where sometimes we see the long-line sequence. We ask the tuning advisor to give a different plan. It comes back with a better plan, and we say that go and implement the plan. It went and implemented the plan. The same query was, for some reason, it's fantastic.
So you have good experience, you have bad experience. Who has good experience with the tuning advisor? 1, 2, 3, 4. Okay. Who has bad experience with tuning advisor? Okay. So we have like mixed experience here, but I would say most people will say it's overstated. I mean, say SQL tuning advisor is not as good as I was expecting to be, right? That's what it seems to be here. But still, I mean, tuning advisor may give you some clues. For example, if I see the tuning advisor is suggesting to implement this profile, I don't implement the profile, but I look at the content of the profile. I look at the hints inside the profile. And if I'm looking at the hints inside the profile, I see these huge scaling factors. Those scaling factors are basically saying estimated number of rows and actual number of rows is way off. So that means the CBO made a mistake. Just by looking at those numbers, that gives me some ideas, I mean, where the CBO is making a mistake. Okay, just keep that in mind. Or if it says, oh, you rather create this index, you may say, oh, I should have this index. Why is this index missing? So in that sense, the tune advisor can give you some hints where to go next. Okay? So now let's talk about SQLTXPLAIN. And I will start with a quick introduction here. So what is this tool? What is this? Well, it's a tool that is available through my Oracle support. That is the node number. And you have the latest version. There is a latest version like once per month. So it has an upgrade like once per month. So it's an add-on tool. It's available on 10G, 11G, it's the same source. But if you need like something for 9.9 or Oracle 8, we still have those versions and they're available. It works on Linux, Unix, and Windows. It can work on a single instance. It's rack aware, it's Exadata aware. It's easy to install and use, it's not intrusive. It doesn't try to consume all your resources. No, it's just one more program that when you run SQLT, it's going to consume some resources during some short period of time. And the one that everybody likes is this one here. It's free. In these days, Oracle doesn't give you a lot of things for free. Okay? So I know that. This one is still free, and I hope it's going to continue like a free tool. It's not in my hands, it's not my code. So far, I mean, we can offer this free, download, and use. This is one of the tools that when a consultant, Oracle consultant, external consultant, doesn't matter. When we start using this tool at the Oracle site, and our customers start looking at the output, is naturally adopted. They say, okay, we like the tool. Can we use this tool enterprise? The answer is yes, you can use the tool enterprise. Why? The whole idea of the tool is to help each other. I mean, since the tool basically collects everything that we need for SQL tuning, it's a win-win. Let me try to explain. Let's say you are working, you're either as a third-party consultant or you're working as a DBA for this Oracle site. I mean, meaning Oracle user site, let's call it that way. You have a performance issue, you have a SQL that is misbehaving. You capture everything out of the SQL with SQLT. If you don't practice SQL tuning quite often, just by looking at the output, it's like a jigsaw puzzle. You start putting things together. You say, I can see adaptive cross-site sharing is here, I can see the execution plan, I can see the statistics, I can see the health checks. When you start looking at everything there are some pieces that you say, oh, now I understand this extra piece. Every once in a while I get as a feedback people saying, I have learned SQL tuning by looking at the output of SQLT, which wasn't the idea, but it's kind of very nice to learn that people are learning SQL tuning just by looking at the output. That is a win. Another win is when it happens that you are stuck on the SQL tuning issue, that you say, when I get stuck on a SQL tuning issue, I go to Able. Okay, that is my to-go person. Everybody has a to-go person. And who is your to-go person when you have a SQL tuning issue?
You are.
I am. So, yeah, sometimes I get stuck on an issue that I cannot handle the issue, I can understand the issue, I go to Able and he can explain the issue to me. Sometimes it's the other way around. Why? Because we have different experience, different way to troubleshoot that with issues, so we learn from each other. So everybody has like a to-go person. Sometimes the to-go person is Oracle. Sometimes you will say, you know what, I'm stuck here, I need to ask Oracle to help me with this issue. If you have all these files collected, that's a huge step. You are helping yourself and you're also helping Oracle. You want to
it's very common in support. I mean, that we have what they call it, let me engage the guru about it. I mean, it is true that, I mean, Carlos and I do this more often and we know more, but there's always somebody else in Oracle that knows more than you do. We rely a lot in each other to solve an issue because we tend to have a different approach to query tuning. And so we build a network of people, and when we start to devise something, we engage the other person, start to discuss it, and sometimes the solution comes along. But it's always paramount that we have all the information there available. I get, in the position that I'm in support, I constantly get calls from other people asking me, I have this issue, I have that issue. The first thing that I ask them is, do you have a SQLT with it? Or do you have it? If they don't have it, I tell them, get it and then we talk. Because whatever I can tell them, or we can discuss in a conversation, or whatever, is pure speculation. Until we have facts, which is what the SQLT captures. Once you have all the available facts, then you can start to work in practice. Then you can start that scientific method. Otherwise, it's astrology, I guess. I mean, when the moon was blue, you got a good execution pattern.
Perfect. Thank you. Thank you. Questions? Comments? Okay, so what are the benefits? The benefits are many. I have a list here. If I summarize the benefits, I would say the one here. At the end, the benefit of SQLT is that it helps to expedite your SQL tuning. It won't do the issue to walk away. It has no magic that is going to say, oh, pass your issue through SQLT and immediately solve. No, it doesn't work like that. It just makes this possible to make the tuning process to be faster. Did I mention this one here? It's free. It's free. So you just keep that in mind. How does it work? Well, there are 5 core methods to analyze one SQL statement. At the beginning, there was only one method. The method was called explain. So that's why the name is SQLT explain at the beginning. But now we have 5 methods. all of those methods, somehow, they will input one SQL statement, and they output a zip file that contains many files inside. Among other things, everything that you see here is included in SQLT. So that means SQLT, it collects from here, put everything together, packages everything, and give you one place with everything that you need. It includes test case. Actually, it includes two test cases, one that is coming from the product and one that is coming from SQLT. So it gives you two test cases ready to be implemented. And it has some other modules and some other utilities. Well, let's start with the 5 core methods. Now, there is here an issue I need to mention. When you install SQLT, it creates a schema. Actually, it creates 2 schemas, and it creates several objects in these 2 schemas. So it has a couple of schemas. So that means it modifies the database. It creates schemas on the database. That's something you need to be aware of. So how do we install SQLT? Usually we download this file, SQLT zip, from this node. When I say usually, because here I gave you the file, but if you don't have the file, you just download the file from this node, unzip into the server, and execute SQCreate. About installation parameters, we do not input the parameters this way. I wish we could, right? We input the parameters command line. So it's like trace analyzer. It's going to ask some parameters, we input the parameters, and the tool is installed. The first parameter is an optional connect identifier. I usually don't talk about this one. I just say in most cases, it just enter nothing, just skip this one. But I'm going to mention this because someone here mentioned that, gave me the clue that you may need this one here. Let's say I cannot access the database server directly. Let's say I am an application developer. I'm given access to the database server, but only through a DNS alias, right? Through a connect identifier. So can I install SQLT over there? The answer is yes, but I need to learn how to do that. And the key is this one here. So I connect to my database or to my SQL process that I can access. And if from here I can access the other database through a connect identifier, I pass this connect identifier. So I can actually, through the connect identifier, I can install the tool on the database. Is that clear? So there is a method to do that. So I provide the password for SQLT, default table space, temporary table space, the main application user. SQLT, when we have someone that is running SQLT, it requires some grants, minimum grants, but we require some grants. Like for example, I need to be able to read the data dictionary. So those grants are assigned to the SQLT user role. So for someone to run SQLT, they have to have the SQLT user role granted. Is that clear? So that is why whenever we install SQLT or whenever we install Trace Analyzer, it's going to say who is going to be using this. So we provide this grant, and if your site is very sensitive about this grant, you can revoke this attribute once you are done. Is that clear? So that's why we have those grants. And the last question that we have is, what is the Oracle pack license that we have? If you have the tuning pack, you say T. If you have diagnostics pack, you say D. If you have none, you say N. Depending how you answer this question, that would restrict the output of SQLT. If you say, go ahead.
But if you have both the tuning and diagnostics, you put TD?
No, just put T. T. Yeah, because diagnostics is included inside T, inside tuning pack. So you have tuning pack, put T. If you don't have tuning pack and you have diagnostics, then put D. You have none, then enter N. Hmm? Yes, you have both, then just put the T. Tuning. Tuning is going to give you everything. Diagnostics is going to restrict the output, and N is going to restrict the output even more. Why? For example, diagnostics is required to expose anything that has to do with AWR. Okay? So if you don't have diagnostics, I cannot access data from AWR. So SQLT, depending how you answer this, is the scope of the output. Any questions there? No? Okay. So once we install, how do we know the installation succeed? Just look at this last line. Okay? If you don't see this one here, guess what? Something was wrong. Let me do the installation so you can see actually how we install SQLT. Very similar to how I installed a trace analyzer. So I'm going to go here to Tools, and on trace analyzer I copy this SQL Plus. I'm going to do the same here for SQLT. So the first step, I'm going to extract SQLT is here, and now I have my SQL Plus alias, so I can open SQL Plus from here. I just click this one, which basically the only thing that I'm doing, I will open SQL Plus from this directory. And I am connected as is to my local database. So the only thing I do is install SQ create. When I do that, it's going to say optional connect identifier. In most cases, you enter nothing, just hit enter. What is the password I want for SQLTXPLAIN? It's case sensitive, enter my password. Default table space, in this case, it's coming with the default of users, which is this one here. Basically what it means is, when I see this one, it means I already have SQLTXPLAIN. This one to try to do an upgrade. SQLTXPLAIN, when you install SQLTXPLAIN and you already have SQLTXPLAIN, it's always trying to do an upgrade. Trace Analyzer is different. Trace Analyzer is uninstall and reinstall automatically. SQLT is always thinking that it's doing an upgrade. So it's doing an upgrade, say, yeah, I will take users, which is what I had before, and I will take temp, which is what I had before. Otherwise, I will have to cut and paste a valid table space name. Now it's saying, who is going to be the main application user? If I say here, this user, the only thing that it's going to do is going to say, grant SQLT user role to this user. That is what is happening. The last question is, if you have license for diagnostic and tuning, you enter T. If you have the license for diagnostics only, then you enter T, otherwise you type in N. So in this case, I type in T, tuning, everything, and it's going to take here a moment to install. Look at the following here. It's saying something about Trace Analyzer. Well, Trace Analyzer can be installed standalone, like we did this morning, or whenever we install SQLT, it also installs Trace Analyzer inside SQLT. So in this case, I can have both. I mean, I can have Trace Analyzer by itself, or I can have Trace Analyzer inside SQLT. So right now what it did, it compiled Trace Analyzer inside SQLT.
Inside the SQLT schema?
Inside SQLT schema. Yes. So I can go ahead and remove Trace Analyzer, and it doesn't affect SQLT, because SQLT, Trace Analyzer is going to be, right now in my system, is going to be installed in two places, by itself and inside SQLT.
So both are installed automatically with this?
Yeah, when you install SQLT, it installs automatically Trace Analyzer inside SQLT. Yeah, but some customers, they may want to install Analyzer by itself and not SQLT. So right now it's compiling SQLT.
So it's creating two schemas now?
SQLT has two schemas, Trace Analyzer has two schemas. Yes. Every time it's doing an automatic upgrade, keeping the repository. So you have anything on the SQLT repository, that one remains there. So this one finished. Again, how do I know the installation was successful? I just look at this line, and it says it was successful. So everything is fine. During that process, it created several log files. So if for any reason it disconnects, one of these log files will have some errors. Right now, since everything went fine and it says it completed successfully, I don't need the log files. I can remove these log files. So if for any reason at some point you try to install SQLT and it disconnects, look at those log files. If you cannot make any sense of the error are usually like table space doesn't exist. or it runs out of space on the table space. Those are typical errors. But if you get one of those errors that is not that trivial, just shoot me an email and I will let you know what to do. Okay? So I'm going to remove those log files, which means we don't need them anymore. So SQLT is installed. How do we uninstall SQLT? It's just a script. I just run this one, SQDrop, and removes the schema owners, it removes all the repository, removes everything. Now let's talk about these main methods. I mentioned before that we have 5 methods. These are the 5 methods. We have SQLT extract, execute, extract combined with execute, explain, and extract standby. What are all these methods? Why do we have all these methods? Well, first, all these 5 methods, they have the same requirement. We need to connect as the application user. Whenever you use SQLT, you need to connect the application user. This is not mandatory, but it's highly recommended that you connect the application user. Okay? Then that application user must have the SQLT user role, except if the user has the DBA role. So you have a user that has the DBA attribute, you don't need to provide this one. But if the application user has no DBA, which in most cases it won't have DBA, then this role should be granted. This happens automatically when we did installation for one user. But if we have multiple users of SQLT, you may want to grant SQLT user role to those users. Okay, so far so good? What else? We need to provide a password of SQLTXPLAIN every time we run these methods. SQLTXPLAIN, the actual user, SQLTXPLAIN, contains the SQLT repository, but it has no grants, cannot do anything. It's very limited what we can do. The reason we have to provide a password here is every time we run SQLT, it exports the repository of SQLT for that one SQL. Okay? In order to do the export, we need to provide a password. So this password is not like we're exposing anything that is sensitive, because everything that is inside SQLT is metadata, and it only has a repository. It has no power to do anything. Is that clear? Every execution of SQLT is for one SQL. So that means if I am concerned about this transaction, I produce trace, ticket off, and I find 2 SQL statements, that means I have to execute SQLT 2 times. One for each SQL. And what else? SQLT has its own set of parameters. These are not init.dora parameters. These are tool parameters, which you set up inside the tool. We usually don't have to set up anything here, but we have like over 40 parameters that we can customize SQLT. Okay, those are the requirements which are common for the 5 methods. Now, those 5 methods, the most common one is this one here, SQLT extract. So the first time you use SQLT, you're going to be using SQLT extract. On SQLT extract, you're going to pass a SQL ID. And that's it. You pass the SQL ID. So let me demo this with the same SQL that we have been using for ACS and SPM. Right now, I don't know what is the state of this SQL. I know we ran this SQL yesterday with ACS, then we ran it with SPM. We created some baselines, remember that? I don't know what is the state. And between yesterday and today, I shut down my database, which is on my laptop. So whatever we did yesterday is not persistent here. But I don't know if you remember, in some of these labs, I had some calls to AWR. Remember that? I was recording some snapshots. So I am guessing that we should be able to find some tracing of what we did yesterday for this SQL. So let's check it out. Let's try to see what is that we can find about this SQL that we executed yesterday, and we executed before we shut down the database and we brought back the database. So to tell you the truth, I don't know what is going to be the outcome, but let's check it out. So I'm going to connect as my user. Now I'm going to say run SQLT extract. When I run SQLT extract, I'm going to say, okay, give me the SQL. Give me the SQL ID or give me the hash value. Well, I don't know what is the SQL ID or the hash value, but it's in some place. So I'm going to look here, trying to find that SQL ID. I don't memorize the SQL ID, but it should be someplace here. When I look at the ACS, and I was trying to run this test on this demo one, it's saying DB1, blah, blah, blah. So let's find the SQL ID. So maybe that has happened on DB. It's not here. But I remember that we saw the SQL ID. So I'm just trying to find out where did we see the SQL ID. On the text file, on the demo. This one here? Yeah, maybe this one has the SQL ID. Maybe this one here, right? Let's try with that SQL ID and see what happens. So I pass the SQL ID, and it's asking me for the password for SQLTXPLAIN. Now it's saying I'm collecting SQL diagnostics, please wait. If I want to monitor what I'm doing here, I can always open another window. I can take this command. I can put it here. And right now it's doing the test case. It's working on the test case builder. I can see that here, test case builder. If I refresh this, it's still working on the test case builder. Test case builder, the 11G test case builder usually takes some time. It's time consuming. It's still working there. It may take a few minutes, so I will let it run. Now it passed that step. Now it's collecting DBA history parameters, segments, collecting DBA segments, metadata. So it's telling me what is that it's doing. It's finding what is the best plan and what is the worst plan. It's creating some reports, a live report. Now it's doing the main report. That SQLT M, that is the main report. It says no rows. So that means it's finished or it's almost finishing. When I come here, it's doing some stuff. I can see some entries here, so it's doing something, right? What is that it's doing right now? AWR. So it's doing something with AWR. What it is, I don't know exactly what it's doing AWR. Something else, it's doing an export. It's just going on and on and on. It's doing some ticket probe. Now it's running something else here. It's running something that's called a SQL dynamic extractor. It's working with DBA objects, and if I have many objects on my database, it may take maybe 30 seconds, maybe a minute to run. But it's doing something, so that is good news. It's working. It's trying to get as much information about the one SQL. And keep in mind, the only parameter that I pass, what do you want here? The SQL ID. As long as I know the SQL ID, it's just trying to collect as much as possible about the SQL ID.
It doesn't matter whether the SQL ID is present in read or SQL.
It's looking for this SQL in memory, and it's also looking for this SQL in history. Wherever it finds the SQL, if it finds it in both places, it's going to give you all the information from memory plus all the information from AWR.
So another question on the password. Is there any specific reason why asking to input a SQLTXPLAIN password rather than role option?
Rather than what?
Rather than granting role?
No. It's asking for the SQLT password because it performs an export of the SQLT repository. So it runs the export. So it requires the password of SQLT because SQLT is the owner of the objects.
Why do you export?
Why? I will demo why. I will get it. Why we have to export. So it completed. So it says, okay, you know what? I completed. My file is identified by this number, 62291. That is the statement ID. And this number that you see here, that is the SQL ID. So it was created. Where is it created? On my local directory. The same place where I run SQLT, which was, remember I double click here on SQL+. So my file is this one here. That is the output. I pass one SQL ID, it produces one file. Now, this file, look at the size of the file. 4 megs. Okay? 4 megs out of the one SQL ID. So what is inside this file? So I'm going to say, unzip this file, and let's check it out. Let's look at the output. Everything that you see here is coming from SQLT, everything collected. I always start with this file that says main. That's the main file, the main report. Let's open the main report. Let me just make it bigger here. And it comes with this menu. In this menu, you will find many links and many entries which are not links. So, for example, I come to SQL text here. If I put the mouse over, it's going to tell me where is this piece coming from. If I open this one, it says, oh, this is your select count. Remember this sequence that we had? If I look at summary, plan summary, it's going to say, oh, for this SQL, I'm finding two execution plans. And they both are coming from memory, okay? And one of them use cognitive feedback. And what is the performance of these two? The performance of this plan was 0.002 seconds, and for the other one was 0.1 seconds. That's what I have. And what else do I have? It's also finding a couple of plans coming from the Turn Advisor. So it talks to the Turn Advisor and it's saying, what do you have for me? Oh, I have this couple of plans. Let me grab those plans so I can see those plans. So if I look at these two plans, doesn't matter which one I take. I'm going to take one of these. Oh, remember this one, the index range scan? If I put the mouse over, I start noticing some pieces. It says, for example, for this index, it says, this index is object 1111183. That is the owner. And the type of the index is normal. It's coming out of this table, T1. It belongs to this query block, and it has these areas of T1. That at cell $1, that is the query block. Remember we saw those on the 10053? What else do we see? It says my current statistics for this object, and it gives me the values. And below it says the statistics for this plan are the same as the current. So what does it mean? Well, if it happens that my execution plan was created yesterday, and yesterday I had a different version of the statistics, I will see here what is the current version of the statistics and what was the version of the statistics I had yesterday. Is that clear? When it happens it's the same, it will just say, oh, it's the same. But if they were different, I will see what was different. Is that? Okay, that is just one small piece. I have the execution order, so I know the first operation to be executed is this one here. I'm looking at the cost, estimated canality. This last starts. I will notice there are some columns that say last, and if I scroll to the right, if this SQL was executed more than once, and here I can see the SQL was executed only one time. If it was executed more than one time, I will see the metrics for the aggregate of all the executions. In this case, this one was executed only one time. The metric that I see here, everything says last, which means the last execution, which means the only execution that I have. So I can see the stars are here, the output rows are here, and on the overestimate, 1x, 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 that means the CBO was very precise, made no mistakes. There are some metrics here, for example, this 7, that means this operation corresponds four blocks itself. Why do I see 7 and I say we have 4 blocks? Well, the index is causing 3 buffer gets. Up to the table, the aggregate is 7. So 7 minus 3, it is 4. That is the most expensive operation. That operation by itself is responsible for 57% of the buffer gets. In this case, these numbers are tiny, but usually what you see here, you see large numbers. So it will show you which operation in the execution plan is the one that is causing the most pain in terms of buffer gets. And the same for times, and so on. And we notice we have some plus signs here. What is the meaning of these plus signs? Let's say that we want to know more about this operation that we have here. Well, this operation, I notice this column that says peak bind. If I open this up, it's using this bind B2, and the value that it passed when the SQL was parsed, it was a value of 5. Okay? If I were to execute the SQL many times, this value here could be different. In this case, it is the same because it was executed only one time. But capture bind, when you execute the SQL many times, every few seconds, it captures the binds that you have executed. Then it's just taking a snapshot of the binds. So let's say it's spinning in one set of binds. It's taking forever in set of binds. In that case, you want to see what was the value of the bind at the time the SQL was parsed, and what is the value of the bind at the time the SQL was executed. Is that clear? So in some cases that this is important, in this case it is not. What else do we see? Well, if I make a reference to bind B2, I would like to see the predicate. So when I open this up, it's going to say, oh, you have this as predicate that says column 2 equals bind 2. That is my predicate. It's projecting the row ID, and it's searching only one column out of this index. So that means this index seems to be that only has one column, but let's check it out. If I come here and I say, show me for this index, show me the column statistics. And this index, I2, it happens to have only one column, right? That column, it has that many rows. I can see the number of distinct values is 11. The low value is -5. The upper value is 5. That's the low and high. Do I have a histogram? Yes, I do have a histogram. Can I look at the histogram? Yes, I click here. And what is this? Remember this from yesterday? That is my histogram. It's showing me the values. And for each value, it's showing me how many rows. And if I use an equality predicate on any of these values, it's showing me what is the selectivity. Okay? What else do I get? And if I come back, and I come back, I can see statistics versions. What is this statistics versions? Well, this index, I am back on this index. We have two versions of the statistics. History, at this time, when I store statistics, I had no statistics, and then I gather statistics here. So that means if I gather statistics multiple times over time, I will see those versions of the statistics for indexes, for tables, for columns.
So if it is analyzed every day, then that many numbers will come, like the last week or something?
Yes, if I gather statistics every day for this subject, it will show me one row per gather of the statistics. So I can see patterns. I can see, for example, the number of listing values have been changing over time, or the low value, the high value, they have been changing. I can see that. Okay. So all those pieces are here. I'm just showing you a small piece of what is SQLT. Tomorrow, on the conference, I'm doing 1 hour session to navigate through the report, different samples of the report, so you get to see what is inside the report. Right now, I'm just showing very high level what is that we have on this report. I'm just going to navigate a little bit more, and then I will move on. Observations. Observation, this is the output of the health check. What kind of observation do we have? It has hundreds, but only those that they come positive, I mean something that says is a concern, are shown here. Just to get some. It says, okay, I'm finding one plan that is using kinetic feedback. There is nothing wrong with that, but it's just letting you know that you have one plan with kinetic feedback. It says, we have no plans with baseline. So that means it's possible that at some point, I drop the baseline. When I was running my script this morning, it's possible that I drop the baselines. Otherwise, the baselines will be here on this line. I will see the baselines.
What about kinetic feedback?
Kinetic feedback is something that we didn't talk about in this class, but that's something that we have on 11G, that when you execute the SQL for the first time, you look at the actual number of rows and compare to estimated number of rows, and if there is a significant gap, it takes those gaps saying, okay, between this number and this number, the factor is this much, and creates a hint in memory, keep that hint in memory, and it forces the SQL to be reparsed the next time. When the SQL is reparsed, it looks at these hints in memory and says, okay, estimated should be this number, but I learned from the prior execution that I should adjust the cardinality by this factor. So it pumps the cardinality up or down according to those factors, and it may produce a different plan.
So is it something like to eradicate, to remove the statistics and then...
No, you don't remove the statistics. Kinetic feedback happens only at the first execution, up to the first 5 executions of the SQL, which is trying to adjust the execution plan by comparing automatically estimated number of rows and actual number of rows. If there is a significant gap, force the hard part of the SQL. So the next time around, it considers that gap and adjusts cardinalities, and therefore the plan may change. Okay, so that observation you're saying, it's a heads up. You have guaranteed feedback. Okay? And many of those observations, they work like this. There is another one here that says, the table is a candidate to be rebuilt. What does it mean, a candidate to be rebuilt? Okay, I may open this one and I may look at table statistics. Table statistics is saying the total number of is gonna compare the total segment blocks. This object has 2,000 segment blocks, and according to DBMS, who uses DBMS space? DBMS space? One person? What is your opinion on DBMS space? You're trying to use this for fragmentation. Anybody else uses DBMS space?
Yeah, I do for the same.
Same fragmentation? Well, SQLT also uses DBMS space in this particular observation, saying, okay, if I ask DBMS space to compute what would be the size of this table if I were to rebuild the table, it's come back and say, okay, this table should be this long, 1920 blocks. But right now, it has this many blocks, so it has more blocks than one actually would be. I mean, in this case, the gap between these two is small. But if the gap were like several times, then the table, you may want to rebuild the table. Is that clear? So SQLT may do many of these health checks using like standard APIs, Oracle APIs, to do validations. So like, I know the actual size of the table, and I know what should be the size if I were to rebuild. I compare these two, and if the gap is more than 10%, then I give you an observation saying, you know what, you have an opportunity here to rebuild this table. And if I were doing a full table scan, Abel, do you want to say something? If I were doing a full table scan and this gap was significant, that is something that you say, you know what, maybe it's time for me to rebuild the table. Okay? Go ahead.
Well, originally, the idea of the observations were to trap a lot of inconsistencies that we saw in databases back in version 10. But I mean, Carlos has been doing a lot of research to put more and more of these health checks and recommendations, not only to trap inconsistencies, but to do all kinds of improvements to the schemas. Like if a column, let's say that a column is a candidate for a not-null constraint, or if you have lots of different features going on in the same SQL, then it's important for you to understand all the things that are in play in a particular SQL statement. Still, all those checks against the statistics are present. We focus a lot, I mean, at least in support, we focus a lot in that those statistics have to be healthy. We have to put it at a name so they are healthy. Oftentimes, the table and the indexes have different times in which they are gathered statistics. Why a customer will gather statistics on a table and not on the indexes or vice versa, we don't know, but we find it a lot. I guess it's because it takes time. Or sometimes the statistics in some partitions are out of sync regarding the main table or other partitions. So there are several inconsistencies that sometimes we scratch our heads and try to ask the customer why they do it, and sometimes just making that little change to make everything in sync fixes the situation, which is kind of amazing. And the last reason we have those observations is to try to catch bugs. Sometimes what you don't know might hurt you. Oftentimes, I mean, in previous versions, we saw that number of distinct values didn't match the histogram. So the histogram reported 10 values, and the number of distinct values said 11. So what happened to the one that we missed? And those kind of inconsistencies created bad cardinality estimations at that plan. And really the issue was fixing that bug in which that statistic was corrupted. So it is highly encourageable to everybody that works with the SQLT to always scan that as observations. Carlos makes a great job adding and improving those health checks with every version of the SQLT, and the SQLT version changes every couple of weeks, maybe a month, but there's always a new version with new things to check. So have it, use it often, and review it, and whatever feedback you have about it, I mean, we're open for it too.
Okay, thank you. Okay, so let me do something here. So you know we have this observation, we're looking at this file. So let's make some changes to the data, and then let's run ACS, let's run SPM. We change the environment, and we run SQLT again to see what is going to be different. So what is that we want to do here? Well, right now we're connected as sys. In this case, this one is connected as the CCRA user. So do I have the T1 table? Yes, I have the T1 table. If I do select a count star from T1, I have 1 million rows, right? What happens if I do delete T1 where row num is less than 100,000 and 100,001? We just delete like 10% of the rows, right? We deleted 100,000, so if we repeat this statement that we have here, we have less data, right? Now let's change some data. Let's do update T1, and we're going to say set C2 equals C2 plus 5, where let's say mod row num and 10 equals 5. We're just changing some rows. This one is coming with this. I don't know what's coming with this. Let's just change here this mod, and we're saying with mod C2 10 equals 2. Affecting data. Then we gather stats. Let's say we gather stats for this one. It's DMS stats, gather table stats, user, and then we pass P1. So what we did, we deleted some rows, we changed some rows, we gathered stats. What else do we want to do? I'm going to exit this one. Actually, I don't have to exit. I'm going to go back to where we have ACS here. I'm going to study SQL+. And here I'm going to do like, if I open the PowerPoint for ACS, on the last slide, it was suggesting to do something. So let me go back to the PowerPoint and see what was the suggestion of the last lab. So I'm coming here and saying, okay, show me these slides. I'm going to check the material. And I'm looking for ACS, the PowerPoint, which was part of the second one here, lectures. And I have articles to share. And on the last slide was saying about the demo. It's saying go ahead and do demo 5. So I'm doing demo 5. What exactly is demo 5 doing? I don't know. Oh, it's running as C, so it won't work, so let me run it here as my user. So I'm coming back here, connect as my user. Then I do demo 5. Execute the SQL, different values, different binds, etc. Then I'm going to do something similar with SPM. if I go back to SPM, I'm going to SQL Plus. I'm just changing the environment around the SQL. Run the SQL and I do demo 1, which was a different demo 1. It's going to delete any baseline that I may have, that's fine. Delete profiles. You run the SQL, at the end it's going to create a baseline. Remember this one that we did yesterday? Let's say that's all we did. So we don't know exactly what is the state of this environment. So I come back all the way, I'm going to close all these windows and I'm going to open a new SQL Plus session, so it's going to start fresh. So if I go back to our SQLT here, and you say SQL Plus, and I'm going to say, let's say in this case, I don't want to connect as the application user. Let's say I want to do SQLT extract connect as is. I can do that. So I'm going to say here, run SQLT extract, and I need what? I need a SQL ID. Where do I find the SQL ID? Well, the SQL ID is in different places, but the SQL ID should be someplace here. I have a SQL ID here. Okay? It's the same SQL ID. So I come back and pass the SQL ID. And I pass the SQLTXPLAIN password. I cannot tell you what is the password, but I'm passing the password here. Okay? So now it's doing something, right? It's going to do another extract. Then once it finishes this extract, I'm going to show you what is different between these two. In the meantime, this is going to take maybe a couple of minutes. In the meantime, I'm going back to the one that we have, which is this one, and I was showing you this report, right? What else do we have? If I show you, for example, this light report, this is like a SQLT but very small. So you're going to show me the performance of the multiple execution plans. It's showing me those plans. I can drill in and solve those plans here. But the format is text-based. You notice everything is text. Why? Because if I want to document this or I want to cut and paste the execution plan into the SR, I can do that very easily because I can just cut and paste from here. Is that clear? Mm-hmm. Also, if I want to check only the statistics, I can come here and say, here I have my statistics for tables, columns. Another thing that I see, remember what it is? The outline? So if I needed like a quick workaround to implement one of these SQLs, one of these execution plans, I can use the outline out of here and put this outline in the SQL. There are many things that I can do with these files. I show you two files, the main report and then the light. What else do we have? Let me see. We have a SQL detail report. I can see that here. That I'm going to show you with the other one. AW1. Why do we have AW1? What is the meaning of having AW1? Well, when we execute this SQL, and if I look at the performance history, this SQL was captured by all these snapshots. And actually, on every single snapshot here, 138, 136, 104, and so on, it captured both execution plans, the good plan and the bad plan. So I have those metrics of the performance of this SQL out of the AWRs. But at some point I may say, you know what, I see those, but I would like to drill in and actually see the AWR. AWR for those time slots. Is that clear? So if I want to drill into the AWR, I can come here and say, you know what, I have 5 AWR reports. Show me what you have. Let me see those AWRs. When I open the AWR, look at the values here. It says from 1001 to 1002. From 137 to 138, 1003, 1004. Those numbers, they match this snapshot that I have here. So I can open one of those reports. And what is this? This is just a standard AWR. So if I am investigating my SQL and I am suspecting something else is going on at the system at the same time, I can go from my SQL to AWR and check what else was running on my system. Is that clear?
What is the trace? SQLT also generates a trace.
SQLT generates a trace file. It depends which method we use. In this case, what I see here is the 10053. The method I use, which is SQLT extract, it doesn't execute the SQL. I'm going to show you one in which we actually execute the SQL, so you can see what else do we produce. But from here, what is this? Remember this that we saw yesterday? Actually, this one contains both. It contains the 10053 and it contains the 10046. What if I come to the plan table? I can see my plan table on the 10053. So now, if I want to investigate how we computed this plan table, I mean how the CBO computed this cost, I have all the details of the computations here. Okay? What else do I have? I showed you AWR. We also have ADDM. Let me open this and show you what is this one here. I open this one and I have for the same intervals, I have these reports. There was no significant database activity to run ADDM. Well, usually it will come with something. One that Evo hasn't seen before, well, I think you haven't seen before, is this one that says SQL DX. Have you seen SQL DX? Ah, okay, then no news. This SQL DX is something new that is going to, it's a dynamic extractor. Everything, let me show you and better. You will see like 5 files inside this one here. And those are the files. But if I show you, let's say I take this HTML file and I open this up, not with a tool, that tool fails when the name is too long, what I can open with this one here. It will come with some entries here. Some entries like what? Like, let's say I want to understand the metadata for the binds. Just for the sake of it. Let's say I have an issue with the binds and I'm suspecting something on the metadata. So I can open this up and it says, okay, this view that is called DBA hist SQL bind metadata, which contains these columns. These are the columns for this view. This is the data related to my SQL. Is that here? This is dynamic, so that means from one environment to another environment, we may get different reports. Just keep in mind, the SQLT, what it's doing is getting everything about this one SQL. Let's see the execution completed. Yeah, my execution completed, and now we have 62292. So let me just go back to 629. This one here is the new one. Let me open the new one and see what is different with the new one. When I open the new one, I'm going to start with the main report. So now I have the two main reports here. I'm going to make it bigger. Maybe not that big, 125. And this one, I'm going to show you also the main report here and make it like 100 is fine. So I'm going to make this 100 so we can see them side by side. Okay. Looks too big. Anyway, this one is giving me an error saying I could not execute the explain plan 4. Why? Because I executed this as is and I should be executing as the application user. It's an error, but it moves on. It gives you everything here. So now if we compare these two, everything seems pretty simple, right? But one thing I noticed that is slightly different. This one has information about ACS and this one doesn't. This one, we can see the big binds and we don't see the big binds here. Let's take a look at ACS, Adaptive Cursor Sharing. I notice I have 3 cursors. Remember this from yesterday, the histograms? They are here. Selectivities are here. The actual big binds, for any of those plans, I can click on the plan and it's going to tell me the values that were used for bind picking. And if there were more than one set of values, I can see those values here, either coming from memory, or they may come from AWR, or they may come from the SQL Tool Advisor. So I can see the binds the Tool Advisor was using, I can see the binds that we stored on AWR, I can see the binds that we have from memory. The amount of information is huge. At this point, you should be either sleeping or overwhelmed, or maybe both. some question that you may have is, how do we look at the system stats and how do we look at DBMS stats from here? So what does it mean? If I come to the main report, I click on this link that says CBO System Statistics. What we notice here, those are the stats that if we were collecting system stats, they will be here. But even if we do not collect these values, the CBO has to use them. So if you see multiple read count is empty, single read time is empty, multiple read time is empty, what happens is the CBO will use these values here. They are not part of the database. The SQLT is basically emulating what the CBO is going to do. CBO is going to compute those values so we can see them here. Now, regarding system stats, it's also showing us here some history. This history is telling me how I have been changing my system stats. Let's say I had a hiccup, and I don't know exactly what happened, but the issue is solved, but I'm trying to do a root cause analysis. So if I am suspecting someone may have changed system stats, I can come here, and I can see all the values, how they were changed, and when. Okay? Keep in mind, SQLT collects current state, and it also collects history, whenever we can collect history. So we have history for system statistics, history for parameters. I don't know if you noticed when I was showing the observations here, there is an entry here that says there are 8 parameters that they have been changed. So if I open this one here, and it's going to say, oh, all these parameters, like a cursor, bind, capture, interval, it has been changing over time, and I can see the different values, parameter server, statistic level. All those parameters is basically keeping track of when they were changed. When I say keeping track, it's not like it's monitoring. No. It's reading this data from history that is part of the AWR. But AWR doesn't show you this data. It's there on the tables, but it doesn't show you the data. So SQLT is doing some data mining on AWR so it can show you when things were changed. Is that clear? Let me see what else. On the second execution, my SQLT extract, when I look at the history, let me go to the same place from both reports. On the first report, when I look at statistics versions, I have 2 rows. On the newest report, I see 3 rows for statistics versions here. What does it mean? That between this one and this one, there was an extra gathering of statistics. When did it happen? Well, it happened here. And look at this value. Remember this value? 900,000 is what we have today. We used to have that many, but now we have 900,000. Now, remember that I changed some data. Remember that I did an update. Let's say I'm suspecting there was some change on the data, but I don't know exactly what may have changed. But I have these 2 SQLTs. How do I compare these 2 SQLTs? I can go piece by piece, compare piece by piece, or I can do something like this. Let me just show you here. I can say, run SQLT compare. When I do SQLT compare, it's telling me my repository has all these entries. And I have these 62291 and 62292, which are these 2. 9192. So I can say, okay, let's take the 91 and compare to this 92 and see what is different between these 2. It's saying, okay, I noticed that for the first one, for the 91, you have all those plans. So which plan I want to compare? Let's just grab any, it doesn't matter. I'm going to take the best plan in both cases, but it could be any plan. And for the other one, since I have the same plan, which is okay, I'm going to use the same plan. But again, I could be using a different plan. So it's doing the compare, and the compare is done. So what do I get out of the compare? It creates this file that says compare. And what I see, it shows me the SQL text. Yeah, the SQL text seems to be the same. SQL identification. SQL ID is the same. Hash value, I have the hash value in one of them, but not in the other one, which is okay. I notice here for the blank hash value, I'm using the same. Well, when we say the blank hash value, and we specify the same, yes, it is the same for Oracle, but SQLT says that here it looks the same But this number is red, so that means it seems to be there is something different on the execution plan, something different. If we compare these execution plans side by side, they may look the same, but there is something that it doesn't match exactly. So let's find out what it is. The signatures are the same for historical lines and SQL profiles. Everything else here is the same. Regarding the environment, there was a small change of environment. The size of the test case, it went from 0.69 gigabytes to 0.07 gigabytes. It may not be relevant, but it may be relevant. The size of the database remained the same, but the objects behind my SQL, there was a small change on size. That's what I see here. In this case, the compare is coming from the same platform, the same RDBMS. So that means I can do compares from development and production, which they could be different platforms, they could be different releases. I can do the compare. Oh, I say in one of the cases you run SQLT connected as the application user. In the other case you run this as is, and it's telling me that. NLS parameters are the same. I/O calibration is not available. CVU environment is coming empty, so that means it's the same CVU environment, the same fish control, the same system stats. When I come to the execution plan, yeah, the execution plan, it seems to be the same, right? It's the same, but it's finding that there is something that is different. What it is, I don't know. Let's try to find out. I can open this. Oh, I know what is different. When I open this more, it's saying I'm searching this column 2, but the execution plan on the right side has no predicates. You notice on the left side, I have the predicate. On the right hand side, I do not have the predicate. Is that something bad? Could be, right? Actually, in this case, if the source for the second execution plan is coming from AWR, AWR doesn't store the predicates for the execution plans. So in this case, basically it's telling me this plan, it seems to be that it's coming from AWR, therefore I do not have predicates. Not a big issue in this case, but in some cases, a predicate may change slightly. Let's say you have two predicates and they swap. If I swap the predicate, does it make any difference or not? Yes, it may. Even if it is an AND operand, if I swap these two, and this one is taking longer than this one here, it may change the performance. From the Oracle perspective, these two plans are the same. But from the SQLT perspective, these two plans are different. Why? Because the order of the predicates change. A small change, but it may imply a significant change in terms of performance. Is that clear? Those are the little things that we can capture from here. Plan information is the same with cognitive feedback, everything is the same. Binds. Yeah, it happens that we're using the same binds for both, fine. Capture binds. In one of them we have capture binds, in the other one we don't. The same happens with the optimized environment. This is just telling me this optimized environment is coming from memory. The other one is coming from AWR. Therefore, we don't have the environment. Plan summary is comparing the performance between these two. So if there is any change in the performance, I will see those values. Red means significant change. In this case, I have 7 buffer gets. In this case, I have 500 buffer gets. And it's the same execution plan and it's the same binds. But it's finding there is something different there. Performance white is fine. This one, as I mentioned before, this one is coming from AWR, this one is coming from memory. Now regarding tables, what do we notice here that is different? Table T1, we have the two executions here. On the first execution, we have 1 million rows. On the second execution, we have 900,000. This is the time that we were analyzed. So it's finding the statistics were changed between one and the other. What are indexes? Is finding different sizes lead blocks, average lead blocks are different. Everything that is different is coming different order. Okay? What about columns? What do you see in columns? Significant changes here. For example, the high value. In one of them is 5, in the other one is 7. You see that? So it's matching all these statistics, tables, indexes, columns, And whenever there is a discrepancy, it comes with a different color. Orange means, yeah, we have discrepancy, but that is still okay. Red, that means we have a significant discrepancy. Is that clear? So with SQLT compare, we can take the metadata from two environments. Could be from the same database, they could be from different databases, and we can compare them and highlight whatever is different. Any question here?
The problem in real case, normally we find out the differences, and what's next?
We fix it. Now the problem is it works like this. In most cases, when we use the compare, is because our customer or our user truly believes that these two environments are really similar. When we run the compare, we notice we have huge discrepancies. Like for example, we find missing indexes, or we find we have histograms in one of them, but not in the other one. Huge gaps between the two. So it's like, okay, you have all these gaps are different. That would explain why I have different execution. Now, what is it you want? You want this bad system to behave as the good system. Well, you have to mimic the same things. For example, if in the good system you have histograms and you don't see the histograms on the bad one, well, you may want to create the histograms, right? Or let's say on the good system you have this index, but in the bad system you do not have the index. It tells you which index is the one that is missing. You say, you know what, we have this index that is missing, you may want to create the index. So you start acting on the discrepancies. Okay. That is a good question I don't recall from the top of my head, I will have to check that out. I know in one of them I did a transformation, in the other one is raw, the way it comes from the database. In this case it shows the same values, but in some cases it may be different if the content is barcode. I will have to check it out. Yeah. So I give you the two of them, but one is the way it's come from the database, the other one has a transformation. Okay, any other question here? Or look at this one here. It's saying in one of them you have a histogram for this column and you do not have a histogram in the other one. And how many buckets we have? We have 255. The other one has only one bucket because we have no histogram. So those are the changes that we start seeing. And in the perfect world, if we're assuming these two systems are equivalent, they should be quite similar. Okay?
What if there is a case on the surface check almost they're all the same, but if you see a different execution? It's like the object seems to have a good stack and everything.
And that becomes complicated. When you see these two are very similar, and we don't get it. I mean, we don't. The next step is to create a test case with each one. Test case. Because if I can create a test case with this system and test case with this one here, and I can reproduce both execution plans, I have everything on my side to narrow what is that is different. Because in order to have different execution plans, something has to be different. The problem is finding exactly what is that is different. But if I can reproduce both plans on my system out of the metadata, then it's easy because it's just a matter of comparing metadata. I compare metadata and I say, you know what, I suspect statistics. If I suspect statistics, then I can take the statistics from this test case and put it to this one here. And if it gives me the plan that I have here, then I know what is the answer. I know it is the statistics. Now it's just a matter of determining which part of the statistics. In that case, there is a module that is called SQLT Exum. Exum because it zooms the statistics from the statistics are dead and their history. And it goes little by little applying statistic changes from one environment to the other, trying to discover what is the plan.
Can you maybe later on show us how to maybe export it to SQLT information from production, import it into text, or non-prod environment to do the comparison? What is the status?
Yeah, sure, I can do that. I can do that. Now, let me do that. That is part of the test case. But right now, what we're covering from here until 5 something is SQLT, test case, check. So if we jump from one area to another, that's perfectly fine. We're going to cover everything. So the question is, how do we get this file and I get from a different system and bring it here, right? So I'm going to do that with an example. Just before I do that, I'm going to show you on any of these two files, there is a README. I show you the main report, I show you the light, there is a README. And the README says, how do I do stuff? It's like, what you want to do, you want, for example, if I want to do SQLT compare. If I want to do SQLT compare, what do I need? Well, it says I need two files, two SQLT files, from two executions of SQLT. They can be from the same system, or they could be from different systems. It could be different methods, different platforms. It doesn't matter. One can be 10G from Linux, the other one can be 11G from Unix, and that's fine. Think compare that we have three systems. Everything could be the same, but it could be three systems. You have two sources and one target. The target is where you do the compare. The only thing I have to do is to bring the repository from the two sources into my target. If everything is the same system, like in the case I run here, I don't have to import the repository. But if I have to import the repository, these are the steps. What you see here. It's saying, okay, in each of your sources, you unzip this TC file, which is a zip file. You are looking for this export, which basically compares the repository, and then import the repository with this command. And that's it. You do it for both sources, and then you can do the compare. Okay? Let me take one of these cases and do it here. But I won't do the compare, I will do the test case creation, which is the same. Let me just show you. If I want to create a test case, it says implement a SQL test case. It's very similar. I need to unzip, but in the case of the test case, I run a script that is going to perform several steps. One of the steps is to import the repository. Okay? Let me show one there. Let me show you what it means. If I come here to the file that I gave you, the material, you have this material, and I go to the one that says samples. I open this one that says samples. Okay? Sample. On samples, I'm going to make a quick detour here for a moment, because I had a question regarding PLC code profiling. Who uses PLC code profiling? Nobody? The question that I had is, what happens when I'm trying to troubleshoot an issue and the issue is coming from PLC code? It happens on a library, and I don't know exactly where the C code. And worse than that, it's possible the performance breaks not from C code, but it comes from PLC code. For example, I have a loop from PLC code. If I trace PLC code, I get every SQL gets on the trace file. But anything that is not SQL, but is PLC code, is not on the trace file. Is that clear? For example, if I'm working with a collection on PLC code, and I scan the collection, that time is not shown the trace file. So in those cases, I want to use the PLC code profiler, and you have these files. These are part of the sample miscellaneous. PLC code profiler, when you execute it, it will show something like this. This is the output. This is another script, another of my tools, which basically builds on top of the PLC code profiler. The node is this one here, 24.37.55.1. And when you run this script, it's going to produce something like this. This one was executed against the apps schema on eBusiness. And it's saying, for my libraries that I profile, it's going to show me here the top 10 lines per total time. And when I look at the lines, it's possible that my consumers, they could be simple, like this one here, but they could be like PLC code calls. Is that clear? Now, when I look at the time consumers, let's say I care for this one that is taking 3 seconds. When I click on this one, it's going to show me the piece of the PLC code block that is consuming the most time. Let me show you a better example. This one is not that clear. Let me show you one here. This one is showing me some rights. Let me see the other one if the other one is better. Just give me 1 second here. Let's say in this case, I have this for I in, this PL SQL. This one is consuming 3 seconds. So if I open this up, it's saying this operation itself, it was executed 3 times and in total it consumed this time. So what you see here is not only SQL, but you also see PL SQL. So when your performance issue is coming from a PL SQL library, PL SQL profiling may help. Okay? So just keep that in mind. So that was just a quick detour. So going back to the sample that I want to create a test case. I'm going to close everything here, and I'm going to go to samples. From samples, I'm going to open this one that says SQLT Qtune. And if I open any of these files, let's say I open this one that says extract. What do I find on extract? I found all these files, and I open the main report, and I can see some SQL text here, right? Now let's say this file is coming from where? This file is coming from a Linux machine, which is an 11203. Let's say I want to create a test case, and I want to be able to reproduce on my test case one of these execution plans. Usually when I'm trying to reproduce one of these execution plans, it's going to be the worst performing plan, which in this case, I want to reproduce this 9 to 5 plan. I want this on my system. Right now, this file, let's assume it's coming from a customer. So I say, okay, how do I take this execution plan and put it on my system? Because I want to play with this. How do I do that? Well, the way to do this, I open the README. Not this one. Let me open the README for this file. It's closing some files here. I open the README, and it says, if I want to implement a SQLT test case, those are the steps. And the steps, first thing it's doing here, is going to say, unzip this TC file. So I look for that TC file, TC, which is here, unzip this file. Step number 1 is taken care of. Now, I need to run SQL Plus, right? So for me to run SQL Plus, I'm just going to copy over these areas over here. And I'm going to open SQL Plus. Fine. I am inside my test case. So what is next here? It's saying you unzip, you go to that directory, and you execute express.sql. Keep in mind, all I want is to be able to bring over this test case to my local laptop. And this file was created some other place, different database, different server, different everything. So I come here and say, express. It says we have to go through 7 steps. First step, I'm going to create a test case user. Do I want a suffix? I say no, I don't want a suffix. What you see there is the metadata to create all the objects behind this SQL. Everything was valid except the package, which is fine in this case. I tried to purge the 53240 from my system. It purged it. Now it's trying to import the repository. The repository includes no application data, it's only metadata. It's going to map the statistics to my new objects. Everything was mapped correctly, I can see that here. It's going to set up the system statistics. It's going to set up the CBO environment with a lot of alteration commands. So it's going to mimic whatever environment I have on the source system. And then it says, I am ready to execute the test case.
It overrides all these objects in the current system?
Yes, but the objects, they have a schema name. The schema name is going to be TC and the name of the statement. So in this case, if I'm working with a statement, the statement is 53240, then I have a new user that is called TC 53240 that contains all these objects that you see here, all the metadata, And the plan that I wanted to reproduce was this one here. Look at this number, 9 to 5. Look at this execution plan. Now, look what I did here, 9 to 5, and look at execution plan. It is the same. So I was able to create a test case on my local database out of the metadata that came with SQLT. Is that clear? It's like magic, right? Black magic. Yeah. So now I can work with this issue because let's say here I have everything, right? Well, I don't have the data, but I have everything else. Let's say for some reason I want to reproduce not this plan, but I want to try to reproduce this plan. Well, this plan that you see here, if I open the outline here, what do you see? That is the plan, right? So I can use this outline on a copy of the SQL that I have from your system and get that plan and do whatever I want. I have my test case, now I can play. Go ahead.
This import going to create a data dictionary object, or it will import the table as well as the actual rows also?
No rows, no data.
Only the data dictionary.
So far, I have never been in a situation in which I require the data. So whenever I do SQL tuning, I do with no data. Okay? Because the way I tune is by the execution plan. So when I have this new plan that I need to be tested, then I prepare a script and I ask my customer to try the script, standalone. Okay? But all the playing, all the tuning happens with no data.
The only time that I had to ask customer for data is when the query was depending on dynamic sampling. So always, there's no API to, at least to level 203 to feed the dynamic sampling. In my case, but in this case, there was a need for the dynamic sampling to be debugged. So that is what I needed, the dynamic sampling to work. So I needed the data to reproduce the issue. But those are very, very seldom appearing cases. Usually it doesn't need data.
Okay, so what I did here basically was like a demo the test case. How do we implement the test case out of SQLT? SQLT includes the test case. The only thing I have to do is take the test case and implement the test case. When I want to do the compare, it's the same thing. It's already there. I just need to bring over the repository, following the steps on the README, and I run the compare. So if you are saying you have production, you have development, you have the same SQL, different execution plans, and you want to know why, I may ask you to send me SQLT from both environments, and I take those two, bring over the repository, and do a compare, so I can see what is different. If what I see that is different, let's say is one index, I may tell you, you know what, you have an index mismatch here. You may want to try to create that index. Can I create the index here? Yes, I can create the index here. I can take the statistics from the system that contains the statistics for that index and put on my index, and I can prove or disprove. A lot of things I can do here on my test case. I don't need to go back every time and say, oh, try this. No. I try to avoid going back and forth saying, oh, try this, try that. If I can try it myself, I rather try myself. Sometimes it takes more time just trying to explain what it is that we're trying to test than doing the test internally. Okay, I want to show you something else that is a little bit unrelated, but doesn't matter. I want to show you that. I am opening the same database from SQL Developer, right? Now, keep in mind, this file, the 5340, is a different database, different everything, different system. What happens if I take any piece here? Let's say I'm looking at this AWR session history, and I'm looking at this history, and I want to get this SQL. Can I take this SQL and execute this SQL on my local database? Does it make any sense? It doesn't make any sense, right? And get what? It's coming with data. And this data that you see here matches the data that you see here. How am I doing this? Everything is metadata. Yes, if I take this other piece that you see here, and I do the same, I take this SQL, That was an enhancement by Evo Macias. He asked me to do this. I take this piece and I put it here and execute. Yeah, I get all that data. Right? So, why do I want to do this? And second, how can I do this? Well, to answer the first question is, reports that they have so many pieces, it's very easy to go like huge report. So that means I have to trim the report. But there is not like a standard report that you can trim the tail of the report. You have to trim in every frame of the report has to be trimmed. So for example, here it's saying this output may include up to 1,000 rows. What happens if you have 3,000 rows out of the SQL? Well, I only include the first 1,000. What happens when you want to see everything? Well, if the report doesn't include that, then you open this up, you take the SQL, execute the SQL, and you can see all the rows unrestricted. Is that clear? So, but in order to do that, that means I need to bring over all the metadata behind your SQL, and that is part of the repository. So when we bring the repository, we bring everything that we need to produce this.
Which step from the which step in your test case build update those methodologies?
Sorry, I couldn't hear you.
So if you run a SQL in the new database, you still got all the data. That means you import it from.
It's part of the repository.
Into the repository, and also because you're accessing all the methodologies, that means you have to update the methodology.
No, I don't have to update the methodology because this SQL, the SQL that you see here, is based on copy of the $views. Look at the name of the object. The name of the object, it says SQLT $GV active session history plan. So it materializes a view that is coming from the GV $view. Yeah, so it's a table. It's actually a table. Is that clear? So if you say, okay, I don't know exactly what is included on SQLT, I'm going to show you here a trick. One of the files that we have are some log files. So let me find the log files. So if I open the log files, and the log files are included on SQLT, so you get to see what it is that you are sending to Oracle. In the log file, there is this file that says export, and this is the log of the export. This is going to tell you, table by table, what is that is exported. This is the repository. And all the SQLT objects, they have the SQLT prefix, but the name, DBA colon usage, DBA constraint, DBA dependencies, so you recognize this name. So that is the source. And this is the SQLT name. And these are how many rows we're passing. For example, for this DBA his parameter, we're passing 75,000 rows. So that means if I select from this table where a statement ID equals 53240, I should get that many rows. Let me just try it here. If I come here and say, select count span from SQLT explain where statement ID equals, and we're saying this one, which is 53240. 53240. I expect to see that many rows. 75658, which it should be the same as we have here. So everything that you see here is part of the repository. I give you the table, where it's coming from, and I give you the rows. If you want to see the content, it's just a matter of doing a select like this one here. If I need to do some data analysis or data mining on the metadata, I can do that. For example, let's say active session history may come with 20,000 rows. What I see here for active session history is only a few rows. So if I want to do an aggregate by object ID, for example, I can do that because I have the metadata. I don't have application data, but I have a lot of metadata. Okay? Questions?
Does SQLT installing it on production and then running it, creating the repository,
Okay, that's a good question. If I install SQLT in production, do I affect the performance of production? Think this way. When you install SQLT, it takes a couple of minutes to install. It may take maybe 5 minutes to install. That is one time. You can do that during a maintenance window, right? SQLT is not monitoring anything. SQLT is just sleeping. It's doing nothing. It's just a tool that is installed, a bunch of SQL packages, and doing nothing. When you run SQLT, it may take a few minutes for one SQL. That is process time. It is running, it's doing something. Once it finishes, it creates a zip file, and it's doing nothing. So the actual impact is a few minutes every time you run it. Okay? And it's not like you're going to take a few minutes of every CPU. No, it's just like any other program. Imagine SQLT is like a program that it may run for a few minutes. That's what it is, and it's pure SQL. For every SQL. Yeah, but you don't run SQLT like every 5 minutes. You run it for those cases where you want to analyze. Normally, you run SQLT for one SQL, I would say maybe once a day, maybe 3 times per week, maybe 5 times per month. It's not something that you keep using all the time. It's only when you want to analyze a SQL that is performing poorly. Disable, yeah. You mean uninstall it? Or what do you mean by disabling? If I want to disable that SQLT user role that I have, I revoke the user role. If I don't have the user role and I try to run it, it's going to fail. Unless I am a DBA. DBA can override that. DBA can run it. But if you're not a DBA and you are a user and I revoke the command, it fails.
In production, we have a problem. The query is really, really complicated. When we run the SQLT, the main report, it takes forever to open. So we have to open the light version of it. What is the major difference between these?
They're quite different. When you say you mean the main report is taking a long time to produce, or it takes a long time to open?
No, it's all produced, everything's fine. When I go to my computer, my laptop, it just takes forever to open.
Use Chrome.
I try that, it takes quite a while.
Okay, let me show you something. When SQLT generates a report, it may be the report is big, right? So when the report is created, it goes through these steps here. Look at this part. It's saying the main report is coming back with 4 megs. The limit is 50 megs. So if it was more than 50 megs, it shrinks the report. So that means it's going to try to resize the report by scaling down all the lists by 50%. So if you saw that list that has up to 1,000 rows, it says, no, now generate the report again, but now the limit is 500 rows. If that fails, then it removes all the go-tos that you see on the report. If that fails, then removes this API that basically allows you to mouse over, to put the mouse over. If that fails, then it scales down to 0.25. And it's doing that 9 times. So it's trying to shrink the report until it fits less than 50 megs. Once I reach the less than 50 megs, I stop shrinking. Okay? The 50 megs is a magic number that says Chrome can take up to 50 megs. More than that, it may hang. So that's another, I don't know who asked me for this requirement, but the same issue. We have this huge report and very hard to browse. So I generate the report, exactly the same report up to 10 times, but shrinking, just to try to make it fit the 50 megs. If that still fails, send me the file, and I will investigate what's going on. Okay. Okay, those are the little things that I usually don't put on a conference unless I mean I have the right question, I give you the right answer. Yeah, SQLT has a lot of little things here and there that basically it's we have thousands of users of SQLT, and guess how many people we have supporting SQLT? One. Part-time. Part-time. Yes, so it's a challenge because if I'm not careful, I will have like several requests to fix something every day, and I cannot handle that. So it's in my best interest to reduce the number of situations in which I have to make a change because something broke. Okay? But that was a good point. Okay, so we have been jumping in SQLT. I showed you the test case, so it's time for me to go back to the PowerPoint and continue with the PowerPoint. We were here. So, We were here on the PowerPoint. We said that the extract, for the extract we found the SQL ID, and you saw what it produces. The second method is execute. Execute, instead of passing the SQL ID, what we pass a script that contains the SQL, contains the binds, contains the SQL. So this method is going to actually execute the script and produce everything. The next method, extract and execute, combine these two. The next one is explain. I suggest don't use explain anymore. Why? Because of the binds. I mean, your SQL has binds, don't use explain. And the last one is extract standby, which is like an extract, but it works on read-only database. So if you have a read-only database, then you run this on the primary, it connects to the standby, grabs everything from the standby, and produces what you need. Okay? So those are the 5 methods. Again, the most popular one is extract. In terms of the output, there is an overlap. There is a common output. The explain provides some more information than the common output. The same happens with extract standby. Then extract and execute, they have a larger output, but they have an overlap here. But there are some pieces of the output they are only provided by execute, and some pieces of the output that is only provided by extract. If you want everything, then you run extract execute, which combine these two. Combine this one and this one, that gives you everything. But if you are beginning with SQLT, I suggest you stay with extract for some time. So you get to use to see what you get. Regarding the report, this report has many pieces. As I show you, we have a health checks, we have SQL text, init parameters, CBO parameters, cursor sharing, adaptive cursor sharing. The output of the tool advisor is also there. Execution plans. We have plan stability. If the SQL has a store outline, a SQL profile, or a SQL plan baseline, they're also included. We have ASH information. Performance about the execution of the SQL. We have the SQL monitor report. Anybody here uses the SQL monitor report? Are you guys seeing the SQL monitor report? Yes? No?
No.
No? Let me see an example, if I have an example here, the SQL monitor report. For the SQL I was showing you here, which is this one, this SQL, I noticed on this SQL I have a hint that says monitor. That is going to force the execution of the SQL monitor report, which looks like this one here. Have you seen this from for Enterprise Manager? Not. Oh, let me change this. Let's fix now. So this is the SQL monitor report, and if you can see it from Enterprise Manager, you can see the execution plan in different ways. You can collapse some of these branches and open them up again. Regarding statistics, you can see steps that may be of some concern. It's very powerful, this report. Is this part of SQLT? It's not that it's part of SQLT, but SQLT also collects this report. So it calls the API, produces the report, and includes the report. This report, as you can see here, is standalone. I mean, you can just open the report and you have the report right there. So it's also there. We have the SQL detail active report, which we can also see that. Where we can see for plan details, we can see different plans, and we can see the execution details for those plans, per execution, per role, activity summary. Many pieces, a lot of information here, which is collected by SQLT. So, questions? You guys may have some questions. No questions? Overall, okay. Let's continue here. So I showed you we have the SQL monitor report, we have segment statistics, session statistics, we have tables, meaning statistics for those tables, we have indexes, object dependencies, policies. If we have policies, like let's say you have a virtual private database, you get to see that. You get to see the policies affecting your SQL. you get all the metadata. You need to spend some time navigating one of these reports. I gave you some samples. On the file I gave you yesterday, there is a folder that says samples, and there are some samples for SQLT. You need to spend some time getting to understand what is that is included. In terms of navigation, I usually go here. I look at observations, SQL text, and summary. Those are my entry points. That's where I start looking around. Depending on what I see there, I go to other places. So I always look at SQL text, observations, and the execution plans. Demonstration, I already did. I already showed you a report. And if tomorrow, if whoever is going to be in the conference tomorrow, if you attend my session, I will spend more time on navigation of these reports. I will take a couple of samples, and I will spend most of the time on the conference is going to be navigating through the report. Why? Because it's huge, and if you have never seen the report before, it's overwhelming. So it requires some time to digest different areas, what is that we look at, what is the meaning of every piece. And every time I explain navigation, I usually take a different path. Because it's so large that it's hard to say, I'm going to explain everything. That is not true. I'm going to explain whatever the conference is taking me. I mean, if I get some questions and people asking about ACS, I will focus on ACS. But it depends on what kind of questions I get. Anyway, let's talk about the health checks. Health checks. I have mentioned health checks. Abel mentioned, there is a question? Yes.
Yeah, so for sites that don't have the tuning pack and diagnostic pack, how much would you say that diminishes the usability of the tool?
Okay, if we don't have the tuning pack and we don't have diagnostic pack, I'm going to lose a lot of pieces. For example, anything that has to do with the history that is stored in AWR, I cannot show you that. But can I show you the history of the statistics? Yes, I can show you that. I cannot show you the history of the plans, but you can see the history of the statistics, right? Can I show you the history of the parameters? No, I cannot show you that because it's coming from AWR. So you lose a lot. To tell you the truth, you lose a lot. You want to add something?
Well, just
go ahead.
Well, the information that it is in the SQLT report is redundant in many parts. So it grabs information from so many different sources that have about the same information or correlated information. So I may not be able to look at the history. Like I said, maybe I don't have the license, but if depending on what is the objective that I'm looking for, maybe I don't need really the history. If I want to see the execution statistics, okay? I cannot see the SQL monitor report, but if I put the statistics level and all, and I run it, I will have the statistics the old-fashioned way. Or if I do the SQL execute, I will get the 10046. So I have the execution statistics. I may not be able to look at the active session history, but I have the wait events of the 10046, which is the next thing. So that kind of redundancy is what makes the SQLT also very useful. Because in support we have to deal with all kinds of situations in which the information is not available. So the more sources we pull it, that's why also we have two ways of, well actually three ways of generating a test case. And on top of that, the scripts there are three ways of getting those scripts, and the SQL one, the main report has also the DDLs from the scripts. Why? Because if one fails, one is not available, we pull it from another place.
Okay, and as long as we're on this thread, one other question. How successful have you been and what caveats do you have if we're diagnosing something at a customer site in production? How much success have you had getting them to install and run SQLT?
I'm going to say 85% of the time the customer doesn't. The other 50%, most of them is because they don't know the tool and they are afraid of installing it. Because they don't know. That's most of the customers. Yeah. Other customers is because of change management. They are forbidden to install something regardless. So You cannot argue with the policy. And less than 1% of them, they had a bad experience and they don't want to do it. I mean, I have some customers say, no, I had a bad experience with it, so I don't want to do it. But after explaining them that the tool goes through several revisions and improvements, then they might give it a chance again.
Yeah, it all depends. I would say that I mean, answering that question, in my experience, that was able experience. In my experience, it's like, I would say like every customer installs SQLT. It's just a matter of time. When I say a matter of time, the first reaction is, no, we cannot install anything in production. We say, okay, let's work on development. Can you reproduce your issue in development? If the answer is yes, everybody's happy because we install SQLT in development and we can do everything there. If the answer is no, and if the customer is quite large, what I usually do, I offer to do like a 1-hour seminar, web conference, so I can explain what it do, what it does, what it doesn't do, how safe it is, the steps to implement the tool. Something like what I did here within 1 hour. And usually what happens after that, they say, okay, we're going to give it a try. And they try it in the test environment. Over time, they see the value, they move it to development, and then they move it finally to production. It may some time. It may take some time, but usually what they do is they take it. Sometimes they say, oh, we are a bank, we cannot do it. Guess what? The biggest banks, they already have the tool. Enterprise, so they're used to do. So it's just like, okay, you are a bank, and there are other banks that are using the tool. So it's like it's just a matter of getting to know the tool, getting convinced, how they can benefit of using the tool. And once they embrace the tool, it's a done deal. But it takes some time. There is a workaround to that. If we start with health checks, because that's a valid requirement. I had another colleague that is Mauro Pagano, you know him. At some point he said, you know what, sometimes we get this pushback that we cannot install SQLT in production because it installs many things. Can we get the health checks from SQLT without installing anything? And I told Mauro, you know what, Mauro, that's a lot of work, because it's basically duplicating everything that we have on SQLT on a different platform, meaning don't do anything on the database, just extract data, but don't mess with the database, don't install anything. And I say no, and then he convinced me through management, whatever. I say, okay, let's do it, okay? And that is the one here. Yeah, because anyway, that's a long story. So we have this health check part that can be executed standalone without installing anything. And that's what I'm going to talk here. Reasons to do health checks, we have many possible reasons. Health checks are basically your friends. When you do some health checks, they will come back with many observations saying, oh, by the way, you may have this situation, you may have this other situation. They are not like a straight pointer saying, oh, this is the root cause. No, they don't work like this. But they're going to tell you, oh, your statistics are bad because of blah, blah, blah. So they give you some heads ups. We do health checks global. We have some health checks that are for e-business, some health checks for SQL. There are different kind of health checks. But everything here is going to be centric to your SQL. And I already show you some samples of these health checks. What kind of health checks we get? Well, for example, the statistics are 88 days old, so that means they are outdated. Or we have some extended stats. Nothing wrong with extended stats, but you need to know that you have extended stats. Or, for example, this one here. You have an index that is being referenced on an execution plan, and that index no longer exists. What does it mean? Well, someone dropped the index, right? Those kinds of observations are important to understand. So, do we have to react to every observation? The answer is no. We only react to those observations that are important. The main question, can we get the health checks without installing SQLT? The answer is yes. The answer is yes. How do we do that? We take this node, and inside this node, we're going to find this script, SQL health check. When we run this script, it installs nothing on the database. It's going to ask for the SQL ID. And it's going to ask if you have the tuning pack or diagnostic pack. It's going to ask that. And after you do that, it goes on and on. And I think it's better if I demo this script. going to close this one here. I'm going to close this one. So I'm going back to where we have the tools. And we have the tools someplace here. I'm going to use the SQL Plus. I'm going to put it where we have the SQL Health Check. Okay. SQL Health Check is here, so I'm going to unzip SQL Health Check can be used. You can download SQL Health Check, or SQL Health Check is also included inside SQLT, but it requires no installation of SQLT. So I'm going to show you the standalone. I come here to SQL Health Check. I put my SQL Plus here. I open SQL Plus and I say SQL Health Check. It says, do you have the tuning diagnostics or not? Okay, I have the tuning back. Tell me the SQL ID of the one that you want to analyze. So, to give you that SQL ID, I'm going to find my SQL ID that I have been using for some time, which is inside tools, ID SQLT, and this is my SQL ID. This F, remember this is the one that I've been using, right? So I'm going to be using the same SQL ID. Could be something else, doesn't matter. When I do this, it's doing the health check. SQL Health Check is going to show me here in front of the screen, it's going to show me what is that it's doing. Why? Because some of these selects are coming from DB dollar bills, they may take some time, so you want to see what is that it's doing. You have a question?
Oh, so you have to do it assist, right?
This one I have to assist, yes. Well, it has to do as a user that has access to the data dictionary. It could be a DBA. The application user usually has no access to many of these objects. And requires no installation. SQL Health Check requires no installation, creates no objects. This one DBA objects is going to take like half a minute because I have many objects on this database. So I know this one is going to take like half a minute. So what is that it's doing right now? Keep in mind, no installation, I just pass the SQL ID. That's it. And I'm going to show you what it is that it produces. At the beginning, when Mauro came with this requirement of having the health checks, and I said no, and then management came and convinced that I had to do this, the first version of SQL Health Check, it only produced health checks, nothing else. Over time, different people have gone say, okay, we have the health checks, but it would be nice if you include the execution plans. Okay, let's put the execution plans. With no installation, same. And then, okay, it would be also nice if you give me the CBO statistics. Okay, let's add the CBO statistics. It would be nice if you include parameters. Okay, and you know where it goes, right? So right now, what it used to be like one page report only with the health checks, now it looks something like this. Let me find that file again on the tools, SQL Health Check. I run SQL Health Check, and it produces this one file, zip file. It looks like SQLT, right? So I open this file, and when I unzip this file, what do I find inside? I find several files. The first one is health check. So if I open the first one, let me just close everything here. If I open the first one, it has some entries here which are basically the environment. What is the SQL ID, the signature, the host, the database release, the size of the block, blah, blah. And then, what do I have here? Observations. These are my health checks. Very similar to SQLT, but this is a subset. It doesn't include everything that we see on SQLT. It's a subset of SQLT. Well, I have several observations. Well, what's enough? They say, okay, give me the SQL text. Okay, that is my SQL text. Give me the summary of the statistics for my table. What about the indexes? They are there. Fine, this one is pretty simple. I have SQL text, table summary, index summary. Well, you notice I have more files. The next file says diagnostics. And when I open diagnostics, this one comes with a lot of pieces here. So what do I have? If the SQL has baselines, it will come with an entry here. This case is coming empty, I have no baseline. But if I had a baseline, it will be here. I have profiles, patches, cursor sharing and the reason to share or not share. No information, my cursors are being shared. I have a SQL statistics. It's history of the SQL statistics out of AWR. What else do I have? I have a, do I see execution plans here? No, I don't see execution plans here, but I see table columns, so I get the statistics for the columns, statistics for the index columns, I have that here. I have system parameters with non-default values, they are there. Then all the instance parameters. I have many pieces. What else do I have? Execution plans. I open this up and I can see my execution plans, I can see the outline, I can see the values of the binds. Okay? And it goes on and on with the multiple execution plans. What else do I get? SQL detail. This is the SQL detail report. Remember I showed you this before. For different execution plans, I get the details. I may get to see the execution plan. Right? For the different plans, I can get to see that. Okay? So there is a lot of information, and remember, it doesn't install anything. Remember this when I showed you this DX, dynamic extractor. Everything that is related to this SQL, the same problem, I come here and extract with this one here. So the name is too long. So I get all those files, and these files, I showed you this kind of before. So let me show it again, this HTML. On the HTML, I have all these pieces related to the SQL. If the SQL is coming from memory, this list contains by 3 times what you see here. I can see, I don't know, advisor statistics. I showed you the metadata before, but I can see SQL set binds. All these pieces that you see. Let me just check one that has some size. Advisor plans. I don't know. I don't even know what is this one here. DBA advisor plans. Those are the columns of this view, and this is the data of this view related to what? Related to this one SQL that I passed. Everything that you see is related to the one SQL that you passed. This is dynamic extractor that basically works like this. You're going to check all the data dictionary, and any view that has a column with a SQL ID becomes an entry here. And then for every one of those views, you're doing the select star from the object where SQL ID equals this value. And it gives you this on HTML, and it tells you the description of each column. So when you're looking here and you say, you know what, I see this column that says, I don't know, ID. So I can see the description of the column here. In some cases, it comes with an actual description of the column. Everything that you see is coming from metadata is dynamic. So that means you get this script and run it on a 12C. It's going to give you the new views from 12C, which may have the SQL ID. Is that clear? You run on 10G, it works. 11G, it works. The content is going to be adjusted according to what is your version of your database. Okay, so that's something new. That DX script is also standalone. So SQL Health Check uses the dynamic extractor. SQLT also uses dynamic extractor. But the dynamic extractor itself, it runs standalone. What does it mean? Just 1 second. What does it mean? I don't know if you noticed here, when we were looking at the health check, it came with these scripts. This is the health check script. Look at this one here, DX. What is this DX? That is dynamic extractor. I can run DX without running health check. And it's going to create the file that you saw here. It's going to create this one file that contains all those files. Let me just finish and then we go to questions. I show you this HTML, but I also have CSV. What is this CSV? If I open the CSV, Abel was talking about redundancy, right? Let me just show you this piece of redundancy. Open the CSV. What do I find here? Oh, I opened the wrong file. So there is I opened the global, but I was trying to open this one here. if I go by size again here, and I'm talking about this advice for SQL plans, it's going to be the same data. The name is too long, the name of the file. So let me try to copy that file to some other place. Just give me 1 second so I can finish this part and then we move on. Okay, I have my data. So why do I care about having my data in two different formats? Because if I have an Excel, I can do graphs, I can do extraction, I can sort differently, I can do whatever I want. I have the data. Remember, this is not application data, this is just metadata. So I have more flexibility by having the data in 2 different ways, HTML and also CSV. Okay? Let's say you want to use the dynamic extractor to something else. Let's say you have this application which is centric to customer ID. So you want to use something like dynamic extractor, but instead of being like SQL ID, it's going to be customer ID. Guess what? You have here the SQL. So you just take this SQL, the one that says DX, open the SQL, and all the scripts that I create, they have my name. The reason they have my name is not to claim ownership. The reason they have my name is because if something breaks, I want to be responsible, okay? So they come documented, they say how it works. So if you can read SQL and PL/SQL, you will find the code is clean. It's easy to be used. It's easy to be reverse engineered. Why? Because I know that someone at some point is going to say, you know what? The idea, I like the idea, but I want to modify this script to, instead of be centric to one SQL ID, I want this to be centric to a customer ID, so I can use it with application data. Is that clear? The concept is the same. You just need to take this script, customize, and the script, this one in particular, is less than 1,000 lines. It's not that big. So it's doable to review this one, modify this one, and make it your own. Okay? Anyway, so I was on showing on the health check, I was just showing you the CSV files, which are here, part of the DX, the one here. And then we have some log files. I show you the execution plans. What is these log files? If I open this up and look at the log files, these log files are for the actual execution of the tool, and it's going to give you the ticket prof sort. Why do I care about the ticket prof of the tool? Well, because at some point you're going to say, your tool sucks, it's taking a long time. Help me to troubleshoot your tool. So I'm going to say, okay, send me the output. So I look at the output, and when I look at the sort here, I will see which statements my tool is executing, like this one here, that are taking some time. So I can see the execution plan and I can diagnose my own tool. Is that clear? So instead of going back and forth saying, oh, you have an issue with my tool, go ahead and create a trace file, then give me a ticket, everything is included. So just give me the output and I can tell you why this tool is taking a long time. Just some pieces here, some pieces there. So let me answer the question. You guys have some questions. Go ahead and ask me the question that you have.
So the SQL help, we can run the SQL help without the DX by a SQL execution.
SQL health check runs standalone. You run SQL health check, is going to ask you for a SQL ID. It installs nothing. If you don't want the SQL dynamic extractor, just remove that script. Don't put it on the same place, because if it is there, it's going to use it. Okay? Any other questions? You guys have some questions?
The dynamic extractor just get to the SQL.
Let me run the dynamic extractor itself so you can see what is the difference between these two. If I am here, the demo I did was with this one here. What happens if I open SQL here and I just say SQL DX? It's going to say the same question. Do you have the tuning path or diagnostic? I say, yeah, I do have the tuning path. And it's going to say, give me the output that you want. You can say HTML, you can say CSV, or you can say both. The default is both. So I'm going to say, give me both. And the last question is asking for the SQL ID. Remember what was the SQL ID? I never memorized the SQL ID. Well, the SQL ID is here. So I take the same SQL ID, right? Pass the same SQL ID. It's doing the DBA objects. So this is basically doing a subset of the SQL health check, and it's also a subset of SQLT. Just the extraction. So it's going to come back with a zip file that contains only the dynamic extraction. I don't know if it is kind of, okay, immediately confusing. SQLT is the big one that requires installation. SQLT includes many health checks and includes the SQL dynamic extractor automatically. SQL health check is smaller. It has a subset of the health checks, and it also executes SQL dynamic extractor, but installs nothing on the database. If you want to go even smaller, then you go with the SQL dynamic extractor, standalone, requires no installation, and it produces only one file that contains some zip files inside. Is that clear? But it doesn't give you any health checks. It gives you the core data. It just gives, it's a dump of all the data that is related to your SQL. So this one is finished, and what it produces, this SQL dynamic extractor, is this one file that is here. This is the one that you just produced. If I open this file, you will see the same content. It has like 5 files inside, which are the HTML, several files, I mean one for each view, the CSV, log files, global tables, and also global tables in these two formats, CSV and HTML. Any questions?
SQLT also contains trace analyzer.
Yes.
One SQLT is all the trace analyzer.
SQLT is the big data. Okay, contains everything. SQLT. That is the one that you want to use. But if you cannot install SQLT because it's production or whatever, then you move to use SQL health check. Okay?
And what triggered you to create a dynamic extract? Since we have the health check anyway.
Okay, the question is why I created SQL dynamic extractor. I was born on weekends, I say. No, the truth is, I was a little bit concerned about 12C. 12C is going to be released sometime, right? When we release 12C, we will have some extra views where SQL ID is part of the view. But I don't know what I don't know, right? So I don't know which views are that. So it will take me some time to find those views, incorporate those views into SQLT, blah. With SQL DX, I have to do nothing. You run this on 12C, and those new views are going to be included on the file. So I have like my backup plan. My backup plan is dynamic extractor is going to get those views, and they will be there. Over time, I will make those views part of the main report, over time. But in the short term, I have the data, I have the metadata, so I don't lose the metadata. Okay? Also happens with new columns. If I have existing views, and let's say SQLT is reading from a couple of hundred views. If I have new columns on those views, the main report doesn't show those columns, but the DX will include those columns.
So is there a way that you can suppress certain items like trace analyzer or SQLT or something from SQLT while installing?
Yes. The question is, can we suppress some items? Not do installation, but actually you can say, don't use this piece. That is doable. That is through the SQLT parameters. Let me show you how it works. Let's say test case builder is taking a long time, because in reality it may take a long time. So what I do in those cases, let me just open any sample of one of the reports. if I look to SQLT Qtune and I look at the sample I have here, let's say when I'm looking at the log file, I discover that the test case builder is taking a long time. I come here where it says tool configuration parameters, and all these are the pieces I can adjust. I have 60 parameters. I told you I have like 40. Well, actually I have like 60 parameters for SQLT. Any of these parameters, if I put the mouse over it, it's going to say what is that parameter for. Let's say, for example, I don't want to generate ASH reports. So if I put the mouse over, it says this parameter tells if we generate ASH reports from memory, from everywhere, or none, right? So I can see the different values here. How do I modify this parameter? The last line here, it says, how do we do that? Let me just open this up a little bit bigger so we can read that. It says, parameters, if we execute this API, passing the name of the parameter and the value, and the name is this name that you see here in this column, and the value has to be one of these values that you have, that change is going to be permanent. If you set this other API, the change is session level. Very similar to Metadata parameters, which you can make it permanent or session level. You can change any of these parameters. For example, trace analyzer. It says, do you want to execute trace analyzer inside SQLT? The default is yes. I can see that the default value is yes, but it takes yes or no. So I can say no, no trace analyzer. You disable that. And you can do the same with SQL Monitor, SQL Tool Advisor, SQL Dynamic Extractor, the one that I just showed you. You don't like that, you want to disable that, you can just change the value to none. Okay? So you can disable many pieces here. Let's say you have partition objects and it's going to, you have 20,000 partitions for this table. You don't want to see 20,000 partitions. So these parameters like what is that I report, you can say, I want to see partitions, so I'm going to go global. I don't want to see the partitions. Okay, here?
It looks like this is after the fact, right? I mean, after you install.
After you install it, yes.
But I guess there is no way to initially self-curve a SQLT installation level itself.
No, and there is no really need. I mean, you install it, so the functionality is there, but if you don't use it, the way not to use it is by changing these parameters. That is easier than trying to control what it gets installed. So I install the tool completely, but then I don't use that functionality controlled through parameters. Okay. Any other question you may have? No?
I saw there the different event. One of the reports is 145. The other event is for the cursor.
The 10507. Oh, it says this one is to trace the current feedback. You can turn this off by using this parameter so I don't get to trace. If you want to see the current feedback, there is no view. For ACS, we have some views. For current feedback, we have no views. Everything happens in memory. But when you turn this event on, you get to write into the trace file some information about current feedback. So you can turn this on or off. And there are some other events, and I give you the events that are also used by SQLT that give you extra information about hash joins, sort-based joins, and so on. And they are usually enabled, but if you want to disable them, you can do that. You have, for example, this mask for values. What is this mask for values? I don't know if you have seen this before, the mask for values. Let's say I don't include application data, but when I show you the low value and the max value for every column, and I show you the histograms, those endpoints, we can see those as application data, especially if the column is like Social Security or is salary. We don't want to show those. So we can mask them, meaning we can replace the value with some string. And we can use this parameter that says mask for values, which has different values. And this text explains which values we can use and what that we get. And so on. There are so many little things on SQLT that unless someone comes and say, how do we change this parameter? I don't even talk about this. The information is here. The syntax to change the parameters are here. But I don't go like one by one of these 60 parameters trying to explain what they do. Because in most cases, you don't need this information, but if you do need this information, it's available. Nothing is hidden, it's just there. How do you eliminate? No, the parameters are here. This is the list of parameters. But let's say a test case builder is taking a long time. That's an example I usually use here. If I look for test case builder here, this parameter, I can disable test case builder. How do I disable test case builder? I execute this API, and where it says name, I say test case builder, that is the name, and where it says value, I pass the value of no. Is that clear? Okay, any other questions that we may have? So that was the health check. So you saw the health check running. I gave you a demo. There is another skill that's called SQL health check execute, which is like SQLT execute. Instead of passing the name of a SQL ID, you pass the name of a script. And it's doing exactly the same, but execute the SQL. It mimics SQLT execute. That's why it's called SQL health check execute. Test case creation. I already demoed this, but let me explain you what it does. Why do we need a test case for SQL2? We're cloning here, right? Test case is like we're trying to clone. We're trying to clone this SQL and the environment around the SQL and put it on a different database where we can mimic the same behavior. So that is why. That's why we need a test case. Why do we want to do that? Because we want to apply what if. Once we have the test case with the execution plan that we saw on the source system, we want to be able to play with it. That's why we need a test case. In some cases, we want to investigate unexpected results. What is this unexpected result? Let's say this SQL is returning 3 rows and you're expecting 4 rows. You say, you know what? I think the SQL is incorrect. There is something going on with the SQL. In those cases, you also need a test case. Okay? I don't want to go into a lot of details about unexpected results, but it happens. It happens that you may have the SQL, you were expecting this many rows, and the output is not exactly what you were expecting. And in some cases, it could be a bug. Okay? So you also need a test case. When you are trying to replicate this case, just be careful. These two, they look alike, but they're not the same. Okay? So sometimes you say, okay, how this case? Well, it's almost like, no. It is, but it is not. Okay? Just be careful with that. So how do we create a test case? We require usually 2 steps: extraction and implementation. Extraction, it happens on the source system. Implementation happens on the target system. SQLT, what it does, it gives you this part already. Every time you run SQLT, you have the extraction. So that means the only thing that you have to do is implementation. How do we implement a SQLT test case? This is what I demoed already. You unzip this file, go to the README. The README is going to give you the instructions on how to do this. And go to the README, get this file, unzip it, and execute the express. That's it. That is the test case implementation. There is another test case which is called test case express, which is this ECX, which is even faster than this one here. This is something new. I'd rather use this one here, even though this one takes a little bit longer. This is more powerful than this one here. This one may not handle columns which are system generated. Like for example, if you have extended statistics, it may not bring over the extended stats. If you know for sure you don't have system generated names for column, you're fine with this one here. Otherwise, we have this one here. This one, I'm not going to say here that even a monkey can use it, but no. This one is basically an easy way to do it. This is for development, actually, because development, they have a requirement. Going through these steps, it may be time-consuming. So they say, we want something faster, and this one is faster. Anyway, that's a different story. This is mostly for internal use. So summary for SQLT. How do we diagnose and resolve SQL performance issues? Or in other words, how is the SQLT help? Well, it helps in different areas. One is that it produces everything that we need for SQL tuning. And when I say everything, it's like, according to our experience, and not only Abel and myself, but a lot of people, it's like, we have on SQLT what we need for SQL tuning, and even more. We usually don't use everything. But usually what we need is already there. Is that clear? So that is what we have. We have over 100 of health checks around a SQL statement. We have the automatic test case extraction. It also generates SQL Tuning Advisor. I didn't show you the SQL Tuning Advisor report, where it's also included inside SQLT. There are some pieces like, for example, commands. Let me just show you what I mean here. Plan stability. Remember the cases I showed you as an example that we have, for one SQL, we have multiple plans. Let me just show you here. In this same case, if I look at execution plans, it comes with several plans. Look at the performance of this plan. This plan performs in 0.2 of a second. This one takes 42 seconds. Different performance. Of course, the number of rows processed is different. But let's just say for a second that we like this plan very much. We want this plan. Or maybe we also want these two. We want these two plans. How do I create a baseline for this plan? I see the plan here. And how do I create a baseline for this plan? The question is, I look at my SQLT, I notice there are two plans that are good, everything else may be questionable, so I want to create a baseline for these two plans. How do I go about creating the baseline? Remember what we learned yesterday about how we create a baseline? We take the SQL, we run it twice, but think this way, I already have the report, I already have the plan. I just want to be able to grab this plan and create a baseline.
You can
Evolve.
use AWR report.
We can use AWR. Well, if the SQL is coming from this AWR, these two, where are they coming from? In this case, they were coming from memory. But this report, when was this report created? This report was created on February 4th. So they were in memory a few days ago. They're no longer in memory, right? So maybe if I was lucky, they were captured by the AWR, but maybe they were not. But anyway, I have those plans here on my report. So how do I take those plans from my report and create a baseline? Can I do that? APIs, I can use with the hints, but instead of going to the hints, I open this README and look for an entry here that says what? Create SQL plan baseline from SQL set. If I open this up, it says you can load one of these plans into baseline, right? If the SQL was coming either from memory or AWR. This method works on the same system where the SQLT was created. So that means if this report was created here on the same database, I can just, for any of these plans, let's say this is the plan that I want, I just take this API and run the API. So I give you the syntax, it's just a matter of cut and paste. What is happening, if you look at the API, what is that it doing this API? Load plans from SQL set. And this plan, the D1316, is already as a SQL set. So that means every time I run SQLT, it's going to create a SQL set for every plan that you see here. Create a SQL set. It doesn't implement the SQL set, it just creates a SQL set. Why? Because it's possible that a couple of weeks later, you say, you know what, I can no longer do this plan. It's no longer in memory, it's no longer in AWR. But I saw it here. Can I grab it from here and implement the plan? The answer is yes. Why? Because when you run SQLT, it creates a SQL set. The SQL set is permanent, it's there, and it's just ready to be used. Take it. Just take this API, run this API, and you get the plan.
You get a SQLT, you get a temporary.
No, SQLT, those always are permanent. And it doesn't matter. It's a tuning set, it belongs to the data dictionary. Actually, that's a good point. It's created in two places. It's created in the repository, SQLT repository, but even if I remove SQLT, still the tuning set is there because it's part of the data dictionary. It's created in two places. This API is using the tuning set from the data dictionary, which is not doing any harm. It's just staying, it's a standby on the SQL set in case you decide to use it. Okay? Now, let me make it a little bit harder. Imagine this file is coming from development, and you want to take this plan and put it in production.
Actually, Carlos, before you go further, can you just go back and show one time how did we get that? How did we manage to actually do the
How do we get this file?
from where?
This is the README, this one here. The README is dynamic. The README that you see inside SQLT, yeah, usually we go to the main report. Main report is here. This is the README. The README is like, what else do I do? I mean, I have the main report to do diagnostics. The README is, what do I do next? What is I can do? So in this case, the README is telling you that you can create a baseline out of the SQL set. Why? Because every time you run SQLT, it creates SQL set for every plan. So you have one plan here, you have another plan here, you have another plan here, another plan here, and so on. You don't have to implement all of them. You can choose and pick, I mean, whatever you want.
This is much more better than the other way.
This is much better than the other way. Which other way?
Like just going the other way, like branded, like
Yeah. Yesterday I showed you how to do this manually. Today I show you how to do this through SQLT. Okay? Now I'm making it a little bit harder. What happens if this file is coming from development and you like this plan and you want to take this plan and put it in production? You have to do an export import of what? The tuning set. Tuning set. So this is what it says here. If you read carefully what it says here, it's going to tell you exactly that. It's going to say, this method only works on the same system where SQLT was executed, unless you first restore a SQL set from a different source, let's call it development, you can restore a SQL set from development, and then follow this API, which basically means 2 steps. You click on this link, and it says, how do I restore a SQL set? So now think this way. This file is from development, and you want to implement the baseline in production. So you come here to restore SQL set, it says, oh, I need to import the SQLT repository. Why? Because the SQLT repository also contains the tuning set. So how do I import the SQLT repository? This is the command. So I take the repository from there and put it into production. Use the SQLT repository. And after I do that, I execute this API. This API is going to unpack the tuning set from the SQLT repository to the tuning set inside production. And after I do that, I can execute this step. Is that clear? If I am...
What would happen when you are importing the repository of SQL tuning set from different? Like it takes only for the particular SQL.
For the particular SQL. For particular SQL and particular plan. Each
so
tuning
it doesn't impact any other...
Nothing. Nothing. The tuning set, the name of the tuning set, you can see that here. It contains the SQLT ID, the plan hash value, and if it is coming from memory or AWR, there are no collisions.
So that can you pick the SQL set?
Yeah, and the other one you also pick here. The SQL set is the one here, which implies SQLT, that is the statement ID. It has the plan hash value, and it has what it's coming from. Where do you get this? On the README, the README file. Okay, the tuning set is created by SQLT. This number 53240, it matches the name of this file, 53240. So that means every time you execute SQLT, even for the same SQL, it creates a different SQL set.
Yeah, but that SQL statement has a multiple plan hash value.
The SQL statement has multiple plans. Yes, that is correct. It doesn't matter. Every plan includes, as part of the name of the tuning set, the plan hash value.
Is that like, I think also if you go back to that other screen where you had that different hash values, I think this might give you that information.
Yeah, this one here, let's say, what is this?
Is it like a deep creating a name or is it like already?
The name is created by SQLT. It's not system generated, it's SQLT generated. So I avoid collision by,
Okay, so one final question.
yeah,
Will that name, the previous screen, from the README file?
from the readme here.
If we select, we take this name and search in the select SQLT, can we find reference to this one?
Okay, this value, 53240, that is the statement ID. And this value, 24 blah 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 316, look at this 316. 316.
Okay,
That matches the plan hash value. Yes, yes. Every plan for every SQL, for every execution of SQLT, generates one SQL set. Okay? So you can select which one you want to implement. If they are on the same system, it's very easy because you only need to execute this API. But if it's a different database, it requires three steps. Import the repository, restore the tuning set, and execute this API. And to import the repository and restore the tuning set, the syntax is here. This is the syntax to import the repository, and this is the syntax to restore the tuning set. Now I can go ahead and do it here. Is that clear? So I can play with my plans. I can take from a SQLT that is 2 weeks old, or maybe 2 months old, I can take this plan from development and put it in production.
All the table names will export, import. The table names are different.
Doesn't matter. The plan is associated to the signature of the SQL. The signature. Of course, it's assuming that your two environments, they have the same objects. Okay? If on development you have table T1 and production your table is T5, it wouldn't work. It's related to the same SQL.
But in the import, you should have. But in the import, you use the import data pump or regular import?
It's export import. We saw that here. I give you the command here. This command is just a standard input. Import of what? I import the repository, right? And after I import the repository from one database to another database, I just need to restore the tuning set and then implement the baseline out of the tuning set. Is that clear? It's kind of confusing. It's clear?
You're exporting the tables that start with SQLT in that import.
Okay. Let me go back. Yes, when I do every time I run SQLT, it exports SQLT repository. Inside the SQLT repository, I have many objects. One of the objects is the tuning sets associated to this SQL out of this execution. So if I just run this API that I have here, I take the tuning set from the data dictionary. Straightforward, from the dictionary. So that means when I run SQLT, it creates a tuning set for every plan on the data dictionary. And then it puts the tuning set also on the SQLT repository. So I have the tuning set in 2 places, inside SQLT and inside the data dictionary. If I want to implement a baseline out of the tuning set, it's going to take the tuning set from the data dictionary. But if I want to copy the tuning set from one database to another database, I already have the export. So I take this export, do an import, and then restore the staging table into the tuning set. How do I do that? These are the 2 commands. This is the import, and then this command is doing the unpack of the tuning set from where? From a staging table that is part of SQLT into the data dictionary by using this name, and this name matches one plan for one SQL.
Okay.
Once I do that, then I can do this on my target system, because now that plan exists, and it's the same plan. This name is the same. Now the plan exists as a tuning set.
Yeah, but Carl, the only thing is that, at least I'm confused about is, so everything is understood what you just said. What is confusing to me is that, that name in between the plan hash value. Now, in order for me to actually make this active, this particular tuning set, I need the entire string, not just the hash value, right? How do I get that entire value?
The string is here. I give the exact syntax. It's just cut and paste.
From where? From where do I get
From the README. This is the README that comes with SQLT. Every time you run SQLT, it includes the README, and the README contains the commands to cut and paste.
This file is, this page is dynamic generated. And can be-
The SQL segment is the one we have to concatenate and generate it with the SQL hash value and plan.
But it's already there. You don't have to concatenate anything. You just need.
Where do you find that? That's what I'm saying.
Where do you find what? I mean, if you look here at the plan summary, like Able is going to try to explain this a different way.
Let me see if I can give. Let me see if I can give you that right. You do a SQL extract on the on a development system. Okay, so you have all those. You see all those language values. Now, when that SQLT extract run, it used the API to create the tuning sets, and the API of the created tuning sets, you can either let the system decide on whatever name he wants to do, or you assign your own name. So Carlos he made a specific name for that tuning set. So the SQL set already has the name, a specific name that was generated at the moment of the SQLT extract was done. Instead of letting I can see what you're trying to say. Well, how do I find out the name? Because you believe that the name is automatically generated by the system. But no, the name is actually given on creation time by the SQLT. So then, because Carlos knows how he constructed the name, then that name follows that SQL set. It's stored in the repository. So when you export it and import it into the new system, that name follows you, and that name is persistent on that SQL set.
Okay, because I was only looking at that plan summary HTML page, right? And in that plan summary, it gives me a list of like 10 different plans.
Yes.
And all I know is that, okay, I want to use one of that plan, which is a good plan, right? So in order for me to get that plan out, I have to do the process.
Yes.
I was just mentioned, right, that all I have to do is I have to go to the README of that particular hash value, and then open it up and then just cut and paste. Is that how it's supposed to be?
Yes, because already SQLT made all the necessary calls to export it and have it ready for you to import it when you need it. Let's say that you didn't have the SQLT. So you already find by making queries on $, views, you already found the specific, the one that you want, the specific hash value. So you have to go to the system again, run a DMS SQL API, and get the plan hash value, then query it again to get the name, I mean the SQL plan name, and then create the tuning set, create the staging table, export it into there, then export it from the to disk, then import it into the other one, and create the table, import the other one, and then unpack it, and then so. You see, all these steps were already automated, were removed when the SQLT ran, because the only thing you need to do is either import the repository, and it will have all the necessary items for you to just cut and paste without any editing. You don't need to change any of the names. The names are dynamically generated already and ready to be used. So you just cut, paste, put it, and that's it.
So the SQLT, when the readme file is created,
I think the question is, in the README, you have only one sample, or for every plan ID?
Every plan has a block.
Okay.
Let me show you the README.
It is
just
not
copy and paste whatever you need.
It is not a sample.
Okay.
It is the actual statement. And if you have 6 different plans, you will have 6 statements because they are the actual blocks to execute.
Yeah.
There is no sampling, no cut them by here and edit this part. There is no something. They are all very.
There will be 6 HTML files, you're saying?
No. In the same HTML file, there will be 6 blocks, 6 different that says this one belongs to this plan hash value, that one belongs to the other plan hash value. All 6 are going to be.
Okay, demo time. Okay, I show you here, from this one, I say, okay, I have these different plans, right? Let's say I want this 316 out of the report, and this report was created on a Linux machine some other place. I already created a test case for this one here, right? So I created this case, I have the others, I have everything, I already import the repository. So when I come here to the README that says, if it is coming from a different system, I have to do an import repository, I already did. So that means what I need to do is, I take the one that I want, this one is 316, this one is 003, and so on. Or let's say the one that I want is this one here. And I execute this one here. So I just did, I mean, as you were talking here, I just executed this one here on my local machine, and it says successfully completed. And after I do that, I take the same 316, took this piece that you see here, that PLC block, and execute it. And this is what you see here. When I do that, it says plans is created one, and it renamed the plan. So the plan that I just created on my local machine is basically this plan. I just copied this plan and put it as a baseline on my local machine. I just did that. Okay? If I want to do it again, let me do it again with another plan. Let's say I want this plan, the 003. So I come here and say, do I need to do this import? No, because I already did, right? So now I'm looking for this 003, which is this one here.
So how do you get that 003? I think that's where I'm
from here, from the plan summary.
Yeah, you got that 003.
Just select whatever I like. Okay, so I took this 003, which has a good performance, right? Right. So I took that 003, execute here, and it says successfully completed. So that means when I am doing this, I have a tuning set, but I don't have the baseline yet for that plan.
Go back to the README part.
Go back to the README.
You see 6 blocks and 7 blocks.
So you get generated automatically.
Everything here is created automatically when you run SQLT. Now, what I have to do now is find this one, the 003, which is here. So I take this API and run it here. Once this one completes, I have two plans on my baseline for those two plans.
Can you show the plan?
Can I show the plans?
What do you expect to use? Plan B? Plan
Hmm?
No, running with the script.
With the script.
The plan B. What's the plan B?
Yeah, the plan B will be required to pass the string. So I'm just going to select start from DBA SQL plan baselines. It's going to come with many rows, but it's okay. Set in. And here I will find several rows. This is the other SQL, the one with the T1. Let me see which SQL we have here. I don't even remember what was the SQL. So let me go back and check. The SQL text is this SQL. So if I look for that SQL, there we are. We can see the SQL. We see the name of the plan. It was manual load, right? These are the two plans. These two. The 003 and the 316. Are they enabled and accepted? I don't recall if they come enabled and accepted. Enabled is this one here. And accepted, where do we see accepted? Accepted is this one here. Enabled and accepted. Enabled, yes. Accepted, yes. Why is it coming enabled and accepted? Let's check the API that we're using here. It says blah blah blah. Load. Alt SQL plan baseline. I change the description. I change the plan name. But when by default, when I load a plan from SQL set, the default is they become enabled and accepted. When I do the auto capture, they don't become enabled and accepted. But with the load SQL plan from SQL set, by default, they are enabled and accepted. Okay? Any questions here? What what is the worst thing that may happen? Let's say by accident I took a bad plan, and that plan is I don't like that plan. Then I can always go back and using the API to change the status of the plan, I go from enable to disable. So it's not, you have a question?
If I install this completely on production,
Uh-huh.
so I ran it on the test and created my test in such a database, and I like the SQL set and then it back to production. But before that I uninstall the SQLT, it won't matter.
Before doing what?
Let's say in production, I remove the SQLT altogether once I took the export of the repository. Then I need to import it again in production.
Yes.
To implement this.
Yes. Yeah, but you don't need to reinstall SQLT. You just follow these steps. So you will need an account that says SQLTXPLAIN, like in this case, but you don't have to install it. Just import the repository.
And if I run SQLT again, let's say take another dump, all these numbers will change.
Yes, that's a good question. You notice every time you run SQLT, we have this statement ID. In this case, it says 53240, right? And if you install SQLT, you will get a different number. And you install it again, you get a different number. Every time you install SQLT, you get a different number. Why? Because this is a sequence, but the sequence starts with a random number. So if you install SQLT in production and development, you have different numbers, there is no collision. The chances of a collision is like 1 in a million. Okay? So no collisions here. Okay, so that this topic, it wasn't necessarily inside the topics I wanted to explain, but it is a little more advanced, but for you guys it is very important. I mean, to be able to, you know this plan, you can take this plan from SQLT and move it from one database to another database. No issues. Okay? Questions? Questions here? How do I do cleanup?
Clean up those SQL sets that you know for sure that you won't need them anymore.
Okay, if you want to do the cleanup, you can use a standard API to do the cleanup. I mean, DBMS and SQL Tune or SQL sets, they have an API. Let me show you an example of how do we do the cleanup. It's not that we want to, I rather have those in case I change my mind. It's like a backup plan. I always have that created. It's not like it's a lot of data because it's a tuning set for one SQL, one plan. So that means it's very little. So I'd rather have it and delete it. But if, let's say I want to delete that. I can use something like this. SQL tuning set. I have to delete the SQL plan management, but the SQL tuning set delete. I have this API that says drop SQL set, and I pass the name of the SQL set and the owner. Where do I get the name and the owner? When I show you those tuning sets here, this is the name and this is the owner. So that means if I run that API and pass these names and this owner, I can delete those tuning sets. If I want to. In general, I'd rather not to. Okay? Any other question? Yesterday I mentioned something about you create a baseline for a modified version of the SQL, and then how do you attach the baseline or the modified version of the SQL to the original SQL. Remember that we mentioned that? And I mentioned, we have a script to do that. Yes. Which script is that? Let me just show you here. On the material, when you look at tools and you on SQLT, you go to UTL, you will find this script that is called COE load SQL baseline. It is the material. When you open this one here, just read the description. So the description is very clear what it does. Just take a moment and read the description. Is that clear what it does? So this is like a an easy way to associate a good plan with a SQL that you cannot modify, but only with hints, but the hints, when you put the hints, are temporary because you cannot modify the application, right? So then run this script. It's going to ask, what is the original SQLT? What is the SQLT of the modified SQL? That means the one that has the hints. And if that one produces multiple plans, which is the plan that you like? Okay? And when you're doing this and you run this script, it's going to do exactly what it says here in the description. This works on 11G, because in 11G we have baselines. If you want to do something similar on 10G, then use this one here, COE load SQL profile.
So basically, you're replacing the hash plan hash value.
You have to go through this script, but yeah, it has to do with the signature, not the hash value, with the signature.
Yeah.
Okay.
So it's enforcing the hint basically.
Let's say you have this plan, it's a bad plan, right? But you know that if you put a hint, you get a good plan. The hint could be a full table scan, could be an index, could be leading, anything. You get a good plan. Fine, you have part of the solution, you know the good plan. But now your challenge is, how do I take that plan that I can only produce with hints and associate that plan as a baseline attached to the original SQL, not to the modified SQL, but to the original SQL. So when the CBO parses your original SQL, it's going to use the baseline of the modified version.
So basically it's stored offline.
No, it's a SQL plan management, it's a baseline. It's not the store outline, it's a baseline.
I mean, but in that case, the baseline only can have this one plan. Otherwise,
no, you can have multiple plans.
But Oracle may not choose this one.
Oracle may not choose this one here.
If I have a 3 plans,
right?
This is modified to one of them. Yeah, but when I run the original query, how can I guarantee the query only use this?
Only to use this one here? Yeah, I agree with you. I can make this one the only plan. Or if I have multiple, I make this one fixed. So always using the same plan.
Yeah.
Okay? So I can do the same with baselines. I can do this with profiles. So these are just techniques. I mean, how do we transport an execution plan from one system to another? Could be on 10G, could be on 11G. If it is 10G, I use SQL profiles. If it is on 11G, I use SQL plan baselines. Okay? Let me go back to the PowerPoint that we have here. We were almost there with this PowerPoint. So some notes that we have. Of course, we have the note for SQLTXPLAIN. We have the note for SQL health checks, a couple of notes for frequently asked questions, and this is my email. Yes, you can send me an email. It doesn't mean I'm going to answer, but you can send me. No, I usually answer all the emails, yeah, and I don't mind. I mean, questions here, questions there. I mean, that's part of my job. I mean, that's what I do. And I also give you this blog. I have a blog. So you can look at the blog. I do some entries on my blog, and for example, I had to write a blog about this topic that we just discussed. I mean, how do we get the baseline from this system to this other system through SQLT? I haven't talked about that on any blog, so I need to write about that. And there is no in between. There is no in between. That is true. I mean, I know some of you guys say, I want this class to be over, I don't want to see SQLT ever again. I know that. I don't take that personal, okay? So, but if you are one of those few that you really like SQL tuning, there are some SQL tuning gurus. I'm not a guru. I'm just here. I mean, my contribution is SQLTXPLAIN and a few things. Well, who are the gurus? I give you just 5 names. There are more names. But if you want to find the gurus, just follow these people. Follow Maria Colgan, Jonathan Lewis, Karin Insap, Christian Antonini, Guy Harrison. I can give you more names, but I think you can start with 5 names.
Where's the Tomcat?
Tomcat, the way I see Tomcat is more like general. He knows a lot about many things. But for SQL tuning, I think these guys here, they have a deeper knowledge of SQL tuning. Say again?
Danto. think that
I have seen it. I haven't gone through his book. He has a book on SQL too. And once I go through his book, yeah, but I know it's good, but it's not my personal experience. I need to go through his book. I have his book, but I haven't had the time to read that. Yeah, keep in mind this list is not all of them, and just giving you 5. So it was hard to say which 5 I should put here. These are the bullets, okay? So you may want to follow them. And that is what I have for this PowerPoint. I have 2 more PowerPoints to cover, which is like 2 more hours, okay? Now, the good news...
You're fine.
I'm fine. I'm already talking to myself on the table. Anyway, the good news is the content of those PowerPoints, I already explained those. So I'm just going to show you what is the content, because it's deeper to what we saw here. I'm just going to go quickly through those PowerPoints so you see what they have. What you will notice, everything that I said is already, everything that is on those PowerPoints, I already mentioned that somehow. So let me just go back and show you those 2 PowerPoints. Yeah, according to the agenda, we have SQL Health Check, which is on SQL Tuning version 1, that is number 12A and 12B. If I go to 12A, I'm going to open both, and 12B. I'm going to close everything else. So this is what is left, those 2 PowerPoints. On 12A is talking about how do we improve the performance by looking at health checks. So this one, it says, well, that's me. Some people say, oh, you look younger. Oh, no, you look older. So I don't know. I just like that picture. That was the last time I was wearing a tie. So that's why I keep that picture.
You were actually expecting me to look like that.
The most.
I was looking for almost, right?
So now I look younger. Thank you. Thank you very much. Okay.
Do I get prize?
I don't have more prizes. I can give you a business card. So anyway, this one it talks about the health checks and do a demo. I already did the demo. So what kind of health checks we do? I mean, first it's talking about what is the health check, what is the input, why do we want to use SQL health check. Sometimes working on a health checks may improve the performance. This is a fact. Sometimes you look at these health checks and you say, oops, I dropped an index. You put the index back and you get the performance. It's true. It's not always the case, but sometimes it happens. Sometimes you just want to do a quick sanity check around your SQL. Now, when do you want to use SQL health check? Is when SQLTXPLAIN is not an option. If SQLTXPLAIN is an option, you want to use SQLTXPLAIN. That is choice number 1. If for any reason you cannot install SQLTXPLAIN, SQL health check is the second best. How do we do that? We download the tool from this node, execute, connect to assist, 2 parameters. If you have a tuning path and what is the SQL ID. When you look at the observations, you don't work on every observation, you just pay attention to those, and some of them are more important than others. We have different health checks. We have global, table level, index level. Now, the actual health checks are over 100. I don't mention all of them here, I just mention some of them here. I'm just going to go through this slide so you can see what kind of health checks we do. Right now we're looking at global health checks. For example, here we're doing health checks about system statistics, about baselines, about client history, about profiles. when we have a data type conversion, implicit data type conversion, when we have predicates out of range, then table level, we check the degree of parallelism, blocks, no statistics, no rows. All these pieces are regarding statistics about the table. Many health checks for tables, sorry, this one here. Then we have health checks for indexes. Number of listing values doesn't match the number of rows. Some cross-reference between statistics, like the number of listing values is not matching the number of listing keys. On an index that has a single column, they should be the same. When we have indexes that are non-usable or invisible. So what is the output? I already showed you the output. The output is quite large. We have many pieces on the output. We usually look first here, observations, so we look at the health checks. All those pieces are from the section that says observations. Then we have a summary for tables, which are basically to do a compare between two systems, but visual compare. We don't have a compare method here. For indexes, we have the same, so we can do a compare between two systems. Diagnostics, we have many entries. I already navigated through some of these entries. On the output, we start here by looking at observations. And then we navigate every other piece. I mean, we look at the table summary, index summaries. We look at execution plans. This is the demo of the SQL health check, which is the one that I executed, and the references. That was the first PowerPoint. We had already covered everything. I didn't go into the detail explaining one by one all the hundreds of health checks, but you have an idea what kind of health check we have. And the last PowerPoint that I have is regarding test case. For test case, I show you how I was able to reproduce the same plan. Remember I took the test case and reproduced the same plan? Remember that? Yes? No? Okay. So here this PowerPoint is how do we create a test case in 5 minutes. Actually the test case is already created. It's how do we implement a test case that is coming from SQLTXPLAIN very fast. And it actually doesn't take more than 5 minutes. So this is an introduction to SQLT. The main point here is the demo, which is what I did. So it has an introduction why we need a test case. What are the pieces that we need? We need metadata, we need CBO statistics, SQL text, we need a similar system. But we also need binds, we need CBO statistics for the system, the CBO environment. We need to remap the schema owner. So if in the source system I have a schema names A, B, and C, I consolidate everything into one schema name, which is called PC something, right? So that means I can create a test case even on the same system. I can create a test case in production. Why? Because it's self-contained. I can do that manually. If I have two environments, let's say production and development, and I have the same objects, I can just migrate the statistics and pretty much I am done. I may need to take care of the CBO environment or maybe system stuff, but doing it manually when the two systems are very similar is easy. Second method is with the test case builder from 11G. There are some APIs. Third method is with SQLTXPLAIN using the TC. This is the one that I demo. Fourth method is this one, TCX, which is more internal. This is new. Those are the four methods. How can we use a test case with SQLT? Well, SQLT gives you the three methods. It gives you test case builder, SQLT test case, and SQLT test case express. We have 3 test cases on SQLT. There are some pros and cons. All the methods, they give you everything. But this one only is available if you are on 11G and only if you use one of these 3 methods. The other methods are available on 10G and 11G, regardless of the method. These two, the SQLT test case or test case express, are very easy to implement. I showed you this one here. I use SQLTC express. This is another method to implement the same test case where I go step by step. This is just one driver that executes all these 7 steps. And this SQLTPCX, you only have the express, but instead of being called express, it's called install, which is just one step, one big step. So where do I find the test case? The test case is inside the SQLT main file, where I can find the main report, I can find the README, and I can find the TC. I need those three. Regardless of which method I use, I may have different files, but in every case I have the README and I have the TC. The TC is a zip file, and the README is just a file that basically contains instructions to implement the test case. Remember, this is the same README that has the instructions to implement the SQLPLAIN baseline. Remember that, like the one that I was showing you? So this README is very important to do things like test case, to do the SQLPLAIN baseline, to gather statistics, to use compare. Those instructions are here on a dynamic file. So what is included on this test case? It has many files. You can see all those many files. Among those files, most of those files are used directly by the test case. We have some metadata script, some purge script, the export of SQLT, some restore script, the setup of the system statistics, the setup of the CV environment, the actual test case, which contains the SQL that we want to execute, and the display of the execution plan. We also have the express scripts, some miscellaneous utilities, and we also have the README. This README that you see here is the same one as the README that we saw for the SQLPLAIN baseline. Remember on Trace Analyzer, I gave you Trace Analyzer in two formats, HTML and text, the same report. And you guys told me the reason is because some people prefer to read text, some people prefer to read HTML. The README here, this one, is the same thing. It's the same content. I give you the same content on HTML and on text. Why? Because if you are working everything on the server, you don't want to go back to a laptop to read the HTML. You want to read from the server, right? So you do a VI, and then you can read this file. It's the same content, or different format, okay? Anyway, metadata script is the one that creates the schema objects. It allows me, if I want to, I can change the name of the test case and add a suffix. And usually I don't use those customizations. I don't have to change those names. So in most cases, when I run the metadata script, everything is going to be fine, everything is going to be valid. In some cases, I get some invalid objects. If the invalid objects are synonyms, I can ignore them. If those are libraries, they may require some attention. If they are views, they do require attention. What kind of attention? I usually need to come to the view inside the metadata and look at the from clause. And if the from clause has a reference to the schema names, I just remove the schema names. It's very easy. This is an example of the metadata script. It contains a small section that we can customize. How many times I use this section so far? Never, never. I didn't create this section to be consumed by myself. I created this section because someone asked me to create this section, so we need to customize. I don't need this, so I suggest you just skip this portion. This purge script is going to avoid collisions. If you send me a file that says 1, 2, 3, or 5, 1, 2, 3, 4, 5, and then another customer sends me the same 1, 2, 3, 4, 5, which means I have a collision, I run the purge script automatically, so I remove the collision. So if I was working this case last week, and this week I'm working this other case for a different customer, it happens to have the same ID, I just remove the problem. This has been here, this provision has been here. So far, I have never had a collision myself. Okay? So collision is like 1 in a million times. I never had a collision. So that would be the purge script. Then the export of the dump file. This dump file contains the SQLT repository. And every time I run SQLT, I have the repository. Keep in mind, I do not bring data, but I bring metadata. About that file, how do I bring over that file? I just issue this command, this import command, and I get the repository. Restore script, that is the one that is going to match my repository to my new objects. So this one is doing the mapping between the object that you have and the object that I have, and it's taking your statistics and creating those statistics inside my object. Is that clear? That is what it does. System statistics is just bringing over whatever system stats you have. How do I bring them over? I delete my system stats and then I restore my system stats using set system stats according to the value that you have. And regarding the CBO environment, this is a script that is going to do a lot of alter session commands and some alter system commands, just a few alter system commands, which is going to allow me to mimic your CBO environment. Whatever you have as your CBO environment, I copy the CBO environment. This test case script contains two entries. It executes the SQL. This script contains your SQL, followed by the one here, which basically displays the plan. When I use the express method, I have a couple of scripts, SH and SQL. SH, basically what it does, it executes the SQL. And this SQL, what it does, it executes the same 7 steps as the custom implementation of the test case. So if I map all those scripts to where they are inside the TC file, they are there. Those are the ones I need. And those are utilities. I already showed you the scripts which are part of the test case, and these are basically extra files, miscellaneous utilities. Now, how do I implement the test case? I unzip the main file, then I will be looking here on the main file. I need the README, I need the main HTML, and I need the TC file. Those are the ones I need. I unzip that, I look at the main report, and then I look at inside the README, I look for this entry that says implement SQL test case. This is going to guide me to say what did I need. This one says copy this file to the target and then prepare the test case. Preparation is very simple. Preparation, this is the README. The README, I just click on this link and it's going to say unzip this file, go to that directory, and then if you do the custom implementation, you follow 7 steps. Those 7 steps, they have pointers basically to scripts inside the test case. But if you choose the express, it's only 1 step. Guess which method we use all the time? 7 steps, 1 step. 1 step, right? So 1 step. But this 1 step, which the shell executes this script, if I open this script, look what I find inside the script. It will find the same 7 steps. Custom and express are the same. Express is just a wrapper, so I don't have to cut and paste command by command. All the commands are here saying step number 1 of 7, 2 of 7, 3 of 7, so on, until 7 of 7. So that means I can go back and forth between the custom implementation and the express implementation. It doesn't matter. If I have to stop at some point and fix something, I start with express. If something breaks, let's say metadata is broken, I need to fix it, then I can come back and either I re-execute the express or I do the custom. In any case, it doesn't take more than 5 minutes. Demonstration, I already did the demonstration. I used TC with the express method. Remember I did that and it was asking step by step? Remember this? Yeah. Okay. So what else do we have? Well, once we create the execution plan that we like, then we can start playing with the what if. What if? Well, what happens, for example, if we have a regression? In other words, we did an upgrade, and after the upgrade, the performance of this SQL broke. We say, you know what, I am suspecting it was the upgrade. So I can say, alter sessions set optimizer features enabled to the prior release, to the pre-upgrade. And if I execute my SQL standalone, and the performance is back to normal, I can pretty sure say, this SQL was broken because of the upgrade. Is that clear? So we can do that. That's easy. And that would be kind of a workaround. I know that if I want to execute a SQL, I just need to do alter sessions, set optimizer features enable, and put it back to the release I had. Run the SQL, and fine. But now, the question is, how do I find which particular fix of the optimizer is the one that is affecting my performance? To narrow that fix, we use this method, SQLTXPLAIN. Now, if we're suspecting it is statistics, I may want to use on a test environment, I may use SQLTXSum. If I am suspecting histograms and I want to modify histograms on my test environment for my test case, I may want to use this method. There are some extra methods, these are advanced methods. So these are basically what happens after we have the test case. How do we play with the test case? Now, if later on I discover, yeah, I have a case, I need to open a bug to development. This is mostly internal. If I want to open a bug to development, I want to create a test case out of my test case, but without SQLT. I want to remove SQLT from the equation. Why? Because if I pass to development a test case where they need to implement SQLT, guess what? They will say, no. Give me a plain test case where there is no tool. Is that clear? So this is basically a method to do that. I won't go to this one because it's mostly from between support and development. How they go from SQLT to no SQLT for the test case. Is that clear? References, the same references, and we are done.